Jawabannya, setinggi apa yang kamu ingin gapai?
Karena tidak ada lagi batas. Kemanapun lintasan masa membawa,
Harapan, hati, dan mata yang berkelana dari masa kini hingga ke masa depan.
Yang sebentar lagi bisa kamu genggam.
Sejauh mana kamu bisa bermimpi?
Jawabannya, sejauh yang hati kamu inginkan.
Dengan energi yang menggerakkan kamu,
Dan kamu. Pertamina, energizing you.
Dari sebuah kepercayaan, kami berhasil wujudkan banyak mimpi besar. Namun perjuangan kami tak berhenti sampai di sini. Gagal, jatuh, penuh tantangan. Tapi kami tak pernah hilang semangat. Dengan terus berinovasi untuk hasilkan produk terbaik dengan sepenuh hati. Berkolaborasi, berkreasi tanpa batas, mengembangkan potensi, menjadi cara kami untuk terus berlari. Sejak tahun 2019, kami bertransformasi menjadi Paragon Corp, yang terdiri dari Paragon Technology and Innovation, perusahaan lokal kosmetik terbesar se-Indonesia, serta Parama Global Inspira sebagai perusahaan distribusi. Kami memiliki 41 distribution center, lebih dari 10.000 Paragonian, dan kami akan terus berkembang. Dengan R&D center terbesar se-Indonesia, kami terus berinovasi menghasilkan brand-brand terbaik. Visi kami adalah memberikan kebermanfaatan yang lebih besar berdasarkan 4 pilar demi membantu sesama untuk kemajuan Indonesia. Mari berbagi mimpi yang sama untuk terus bertumbuh, berkolaborasi, mengembangkan potensi bersama Paragon Corp.
We'll start very soon. Thank you. Selamat datang di Hotel The Stones Legian Bali Autograph Collection. Keselamatan Anda adalah prioritas utama kami. Kami ingin menunjukkan kepada Anda prosedur keselamatan dan keamanan dalam situasi darurat. The Stones Legian Bali dilengkapi dengan sistem kontrol yang dipantau selama 24 jam. Ruang pertemuan di hotel kami telah dilengkapi dengan alat pemadam api, pemercik air, pendeteksi asap, sistem audio publik. Ruangan ini memiliki 2 rute evakuasi. Pada saat terjadi situasi darurat, mohon untuk tidak panik. Tim tanggap darurat kami siap membantu Anda. Jika terjadi kebakaran, tinggalkan ruangan dan ikuti tanda keluar. Ikuti associate hotel yang berbaju oranye menuju fire assembly point di pintu masuk utama Hotel The Stones. Saat ada peringatan tsunami dari sistem audio public hotel, jangan lari keluar. Ikuti associate hotel yang mengenakan rompi berwarna oranye untuk melakukan tindakan evakuasi ke area rooftop ballroom. Saat terjadi gempa, menunduklah atau lindungi diri Anda di bawah meja. Mohon untuk melakukan tindakan evakuasi hanya setelah gempa berhenti. Terima kasih atas kepercayaan Anda. Semoga Anda mendapatkan pengalaman yang menyenangkan di Hotel The Stones Legian Bali.
In the future. To begin, allow me to extend sincere welcome to the Head of National Research and Innovation Agency, or BRIN, Dr. Laksana Trihandoko, the Head of Research Organization for Energy and Manufacture, BRIN, Dr. Hasnan Abimanyu, who today is represented by Dr. Hans Saputra, all the head of research centers under the Research Organization for Energy and Manufacture, BRIN, Dr. Wijo Kongko, Dr. Mahfuz Alhuda, Dr. Cuk Supriyadi Alinandar, Dr. Teguh Mutaki, Mr. Nugroho Adi Sasongko, PhD, and Dr. Aam Muharram. The Secretary General of Indonesian Researchers Union, or PPI, Dr. Sri Jangkung Sumbogo Murti. To our honorary keynote speakers, Professor Heri Hermansyah, the Dean of Faculty of Engineering, University of Indonesia, Professor G.M. Safiullah, Associate Professor at Murdoch University, Australia, Professor Shabir Giwala, King Mongkut's University of Technology, Thailand, Dr. Yelena Popovic, Associate Professor at University of Twente, Netherlands. We would like to extend our gratitude to our generous sponsors who made this event possible. PT Pertamina Persero, represented by Dr. Oki Muraza as the Senior Vice President of Research and Technology Innovation. Paragon Corporation, represented by Dr. Sari Khairunisa, dermatologist, as the Vice President of Research and Development. PLN Engineering, represented by Mr. Hengki Setiawan as the Vice President of Marketing. Huawei Indonesia, represented by Mr. Ali Hanif as the Business Development Manager. PT Experta Adi Manusa, represented by Mr. Adi Ruhiat as the Director. Geodipa Energy, represented by Mr. Yudistian Yunis as the President Director. PLN Nusantara Power Services, Mitratel, GMF Aero Asia, represented by Mr. Mukhtaris, Director Line Operation GMF Aero Asia. Bank Jabar Banten, represented by Mr. Muhammad Hartami as the South Tangerang Branch Manager. All the invited moderators, especially from Pertamina University, PLN Technology Institute, and Polimdo. Our partner in organizing this event, PT Apseri Solusi Prima, Miss Elianora and team. Our publisher partners, IOP Conference Series, Evergreen, and MEV. Next, of course, the chairman of ICSEEA 2024, Ms. Hafsa Halida, and all the team members who work hard to make this event happen. Lastly, to all esteemed presenters and participants, let's give the warmest round of applause for all of us. Ladies and gentlemen, the organizer of this event have chosen Bali as the place for our conference. Famous for its cultural richness, beautiful natural landscape, thriving arts community, and warmth of hospitality, Bali promises an unforgettable experience. Moreover, starting from today until a few days ahead is the Galungan Days. It is a Balinese Hindu festival that celebrates the victory of Dharma or goodness over Adharma or evil. During this time, Balinese families hold special prayers and offering to the gods and ancestors. We extend our hope that you will not only benefit from this enlightening conference, but also enjoy the splendor that Bali has to offer. Before we start, two very important announcements. First, at the end of this conference, there will be evaluation for the best presenters and the best papers for each topic will be awarded. So please do your best. Second, as a form of appreciation from the organizer to the audience, door prizes will be offered during the session. The winners will be selected by participating in a quiz. Therefore, we kindly request everyone to join the entire agenda to ensure your participation. Ladies and gentlemen, as a gesture to respect the host country of this conference, let us proceed to the first agenda, singing the national anthem of Indonesia, Indonesia Raya. Ladies and gentlemen, please raise. Thank you. Please be seated. Ladies and gentlemen, to know deeper about this conference, I would like to extend an invitation to the chairman of ICCEA 2024 to present the report. Please welcome Ms. Hafsah Halida.
Yes. Okay. Thank you, Ms. Novi. Okay, Bismillahirrahmanirrahim. Ladies and gentlemen, I would like to start my report by welcoming with a lengthy list of people who make this event possible. So please bear with me for a little while because I have a lengthy list of people. The Honorable Dr. Laksana Trihandoko, Chairman of National Research and Innovation Agency, Representative of Dr. Hasnan Abimanyu, Chairman of Research Organization for Energy and Manufacture, all 7 heads of Research Center BRIN in Research Organization for Energy and Manufacture, Dr. Wijo Kongko, Dr. Hen Saputra, Dr. Mahfudz Al-Huda, Dr. Cuk Supriyadi, Dr. Teguh Metaki, Mr. Nugroho Adisasongko PhD, and Dr. Aam Muharrem. Our today's keynote speakers, Professor Dr. Heri Hermansyah, Dean of the Faculty of Engineering, Universitas Indonesia, Dr. J.M. Syaifullah, Associate Professor at Murdoch University, Australia, and Professor Shabir Giwala, who will be joining us online today, Professor at King Mongkut's University of Technology, Thonburi, Thailand. Next, I would like to welcome our sponsors from Pertamina, Dr. Oki Muraza, Senior Vice President of Research and Technology Innovation. From Paragon Corp, Dr. Sari Hairunisa. From Huawei Indonesia, Mr. Ali Hanif, Business Development Manager. From PLN Engineering, Mr. Hengki Setiawan, Vice President Marketing. From GMF Aero Asia, Mr. Mukhtaris, Director Line of Operation. And our invited moderators, who will be joining us online, Universitas Pertamina, ITPLN, and Politeknik Negeri Manado. Also, my heartfelt welcome to our partner, the Indonesian Researcher Union, or PPI, which represented by the Secretary General, Dr. Sri Jangkung Sumbogomurti, and PT Apsari Solusi Prima, Miss Elianora and team. And lastly, to all presenters and attendees joining us both online and on-site. Assalamualaikum warahmatullahi wabarakatuh. Let us offer praise and gratitude to the presence of Allah Subhanahu wa Ta'ala, for it is by His grace and mercy that we have the opportunity to participate in the 11th International Conference on Sustainable Energy and Energy Engineering and Application, or ICSEEA 2024 in Bali, Indonesia. As the chairman of this conference, it is both an honor and a privilege to stand before you today. Ladies and gentlemen, allow me to elaborate on the overarching theme and conference scopes of ICSEEA 2024. The central theme of our conference revolves around transforming energy, industry, and transportation technology towards a decarbonized society. This theme is structured around three primary scopes, which is new and renewable energy, sustainable transportation, and green maritime technology. Ladies and gentlemen, according to the International Energy Agency in Paris, achieving net zero carbon emissions by 2050 is a key step in building a carbon-free society. The energy and transportation sectors currently contribute roughly 3/4 of global greenhouse gas emissions. However, efforts to curb carbon emissions from fossil fuels in these sectors must also align with strategies addressing emissions in other sectors. The maritime industry, for example, is accountable for approximately 2.3% of global carbon emissions. If treated as a nation, the maritime industry will rank as the 6th largest carbon dioxide emitter, which is a very, very high rank. On the other hand, in the local context of Indonesia, Indonesia has set a goal to become a global maritime superpower by its centennial in 2045. So, green maritime technology is a new edition of the scope of ICSEEA 2024, which is hopefully emphasizes the importance of implementing a more eco-friendly solutions in the maritime sector. Ladies and gentlemen, I am deeply humbled to witness the convergence of brilliant minds in this event. There are 59 presenters today from new and renewable energy, 36 presenters from sustainable transportation, and 7 presenters from green maritime technology. All 102 presenters will share their knowledge and innovative insights with us for 2 days of this event. During our time together, I encourage each of you to actively participate in the various sessions. This conference will feature 4 parallel sessions each day, comprising 1 offline session and 3 online sessions. Participants can engage with the content that matters most to them. Ladies and gentlemen, on the second day of our conference, which is tomorrow, we will host a series of industrial talks, where representatives from various industries will share their experiences and insights on decarbonization efforts. These sessions will offer real-world examples of sustainable initiatives, providing us with practical insights towards a greener industry. In conclusion, I extend my heartfelt gratitude to all of our participants, speakers, sponsors, and organizers for their invaluable contributions to ICSEEA 2024. Together, let us seize this opportunity to learn, grow, and make a meaningful impact on the world around us. Now, ladies and gentlemen, allow me to end my speech with a short poem, or as we call it here in Indonesia, a pantun. In Bali, oceans are blue, and the sunsets are the best. Thank you, and may this conference be a resounding success. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Hafsa. Distinguished guests and participants, our next agenda is the welcoming remarks from PPI, or Indonesian Researchers Union. I kindly request the Secretary General of PPI, please welcome Dr. Sri Jangkung Sumbogomurti.
Bismillahirrahmanirrahim. The Honorable Chairman of the National Research and Innovation Agency, the Honorable Chairman of the National Research and Innovations Agency, BRIN, Dr. Laksana Trihandop. The Honorable, the Head of Research Organization for Energy and Manufacture, BRIN, Dr. Hasnan Abimanyu, who today is represented by Dr. Hensa Putra. Our honorary keynote speakers, Professor Heri Hermansyah, the Dean of the Faculty of Engineering, University of Indonesia, Professor G.M. Saifullah, Associate Professor at Murdoch University, Australia, Professor Sabir Giwala, the King Mongkut University of Technology, Thailand, Dr. Jelena Popovic, Associate Professor at the University of Twente, Netherlands, the Tribune Networks as a PPI partners, our sponsors such as Pertamina, Paragon Corp, PTPLN, and others. Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Peace be upon you. Good morning. Praise and gratitude we pray to the presence of Allah Subhanahu wa Ta'ala so that we can gather here to take part in the International Conference on Sustainable Energy Engineering and Application 2024 with the theme of transforming energy industry and transportation technology toward decarbonized society. I represent today from the Indonesian Researchers Union or PPI. We express our gratitude, and it is with great pleasure and honor that I stand before you today as we gather for this esteemed occasions to organize the international conference. This event marks a significant milestone, bringing together brilliant minds and experts from various corners of the world to engage in the meaningful discussions, share knowledge, and foster collaborations. In the ever-evolving landscape of energy research and innovations for sustainable future, we must come together and explore innovative this This internal conference provides a unique platform for scholars, researchers, and professionals to exchange insight, challenge existing paradigm, and collective contribute to the advance of our shared knowledge. Our world is interconnected in one's unimaginable ways, and the challenges we face are increasingly complex. Thus, the importance of international collaboration and cross-disciplinary dialogue cannot be overstated. This conference serves as a bridge connecting us cross-border and disciplines and empowering us to address global issues through a collective and diverse perspective. As we embark on this intellectual journey over the next 2 days, let us embrace the opportunity to learn from one another, question assumptions, and seek solutions that transcends geographically and disciplinary boundaries. The diversity of thought and expertise gathered here today is our greatest asset, and it is through open dialogue and collaboration that we can make lasting contributions to the advance of research and innovations on sustainable energy. And last, I would like to extend my deep gratitude to all participant keynote speakers, sponsors, and of course, organizers who have worked tirelessly to make this international conference a reality. Your dedication to the pursuit of knowledge and betterment of our global community is truly commendable. In conclusion, I wish every one of you a fruitful and enriching experience during this conference. May our discussion be insightful, our connection meaningful, and our collective efforts contribute to the progress and prosperity of our shared idea force. Thank you, and let the International Conference on Sustainable Energy, Engineering and Application 2024 begin. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Sumbogo. Now we would like to turn our attention to the welcoming remarks from the Chairman of the Research Organization for Energy and Manufacture, BRIN, who today is represented by Dr. Hans Saputra, the head of the Research Center for Industrial and Manufacture Technology. Please welcome Dr. Hans Saputra.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning, ladies and gentlemen. The Honorable Chairman of National Research and Innovation Agency, Professor Laksana Trihandoko, the Chairman of Research Organizations, Energy and Manufacture, the Chairman of Indonesia Research Union and the General Secretary, distinguished keynote speaker, Professor Heri Hermansyah, Professor J.M. Saifullah, Professor Sabir Jiwala, distinguished Head of Research Center within BRIN, all of the speaker and participant. First of all, I would like to praise and thank God, the Almighty Allah Subhanahu wa Ta'ala, who has granted countless blessing and help for us, so we can meet together in this international conference, the 11th International Conference on Sustainable Energy, Engineering and Applications, ICC 2024. This event will be held today and tomorrow, 28 and 29 February 2024 in Bali, Indonesia, and will be attended hybridly online from all over the world. My name is Hans Saputra, Head of Research Center for Process and Manufacturing Industry Technology, act as representative of Head of Research Center, Head of Research Organizations for Energy and Manufacture, National Research and Innovation Agency, BRIN. We hope that this international conference can become a medium for transferring knowledge to the governments, science and technology, human resources, such as researchers, lecturers, students, industry, and society, regarding the transforming energy, industry, and transportations toward the carbonized society. I think this theme is very relevant to current conditions and as preparation for the facing in the challenges in the near future. Ladies and gentlemen, hopefully we can strengthen the research and innovation ecosystem through various collaborations. I am looking forward to fruitful discussion at this international conference. Honorable Chairman of National Research and Innovations of Republic Indonesia, please give us the directions and officially open this international conference. And thank you very much for all of the supporting our sponsor and our partners. Thank you very much to all of your attentions. And I'm very sorry if there are any mistakes or inconvenience during the conference. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Hans. Distinguished guests and participants, our final welcome address will be delivered by Dr. Laksana Trihandoko, the head of the National Research and Innovation Agency. While Dr. Handoko is unable to join us in person today, he has thoughtfully prepared a recorded video message for all attendees. Please start.
All of you, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera untuk kita semua. On behalf of the National Research and Innovation Agency, BRIN, I would like to extend a warm welcome to all of you and distinguished keynote speakers, guests, and all participants. This year's conference bring a theme on transforming energy, industry, and transportation technology towards decarbonized society. This shows a statement to our collective commitment to a sustainable future. Ladies and gentlemen, the commitment of Indonesian government to carry out the energy transition has been manifested during the G20 Presidency Summit 2022 in Bali last year, whereas the energy transition became one of 3 priority issues already discussed. In regard to the issue of energy transition, the G20 Presidency Summit last year has succeeded in producing what we call as the Bali Compact or commitments, which is consisting of 9 principles of accelerating the energy transition, with some focuses on the availability of and affordability of energy access. Secondly, the world energy security, the fairness of the energy transition process. The Bali Energy Transition Roadmap is a roadmap toward to the fairness for implementation of the energy transition. These 2 documents become our guide for achieving the agenda of SDGs in 2013 and establishing a roadmap towards net zero emission of carbon neutrality according to national conditions. Indonesia recognizes the importance of accelerating and development and deployment of technology, as well as the implementation of this transition policy towards to a low emission carbon in energy system. Including in this policy, we are in the effort of rapid deployment of clean power generation, utilization of the renewable energy sources, and also the implementation of energy conservation, as well as the effort to make early retirement on our coal-fired power generation. Those policies should in line with existing national energy conditions and needs to support our way on energy transition. Indonesia reaffirms the commitment of achieving the targets of SDGs 7 and working for bridging the gap of the energy access as well as to eradicate energy poverty. Realizing of the Indonesia's role and according to the Bali Compact and the Bali Energy Transition Roadmap, Indonesia has committed to find a solution for achieving energy market stability, transparency, and also affordability. Indonesia will accelerate the transition to afford our climate policy goals through strengthening the energy supply chains, energy security, as well as diversifying our energy mix and system. Ladies and gentlemen, within BRIN, we are deeply committed to advance scientific research and innovation that addresses the complex challenges facing our world. As we are gathering here in Bali for the next 2 days, we are very privileged to have experts, researchers, and industry leaders from around the globe here. This hybrid conference encompassing both online and offline participation brings together the very best minds across disciplines. Taking this opportunity, I would like to convey how we should, and this conference should, foster deeper collaboration between academia, industry, and government, breaking down barriers and accelerating innovation. Secondly, amplify also the voices of researchers and provide them with opportunities to showcase their innovative solutions. And also to connect with international colleagues and share best practices from diverse regions and perspectives. And lastly, also to develop concrete strategies for implementing sustainable solutions and addressing real-world challenges. Ladies and gentlemen, after the establishment of BRIN in 2021, we are not only an executing agency conducting any research in a broad range of research fields, but also we are the main supporter for what we call as the science and evidence-based policy, including the energy policy. And secondly, BRIN is also the funding agency to strengthen the national research and innovation ecosystem. So before concluding my remark, I would like to extend my heartfelt gratitude to all of you, the participants, sponsors, and organizers who have made this conference happen. I wish all of you have enjoyable and fruitful discussion during this conference. And concluding my remark, I hereby officially declare that the 11th International Conference on Sustainable Energy Engineering and Application, ICSEEA 2024, open. Thank you very much. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Handoko. Distinguished guests and participants, as I mentioned earlier, Bali is famous with its cultural heritage. One of them is beautiful and unique dance. To feel the vibe of Bali and to enjoy the beauty, we would like to present to you Sekar Jagat dance. Sekar means flower and Jagat means universe, so the name translated to flowers of the universe. The Sekar Jagat dance often depicts themes related to nature, beauty, and harmony, reflecting the cultural richness of Bali. Our dancers today are three ladies. They are Miss Nikadek Tali Titikasih, Miss Niwayan Alit Pridayanti, Miss Nimade Sri Kanti. Ladies and gentlemen, please enjoy Sekar Jagat. Please give the biggest applause for our dancers. Thank you very much. I would like to invite the dancers to come back to this room because our next agenda is photo session. And we would like to invite all distinguished guests and participants to come to the stage so that we can take pictures together. Please, we welcome everyone to come to the stage so that we can take a group photo. Also to the dancers, please give applause once again. I think they're so beautiful, right? Yeah. Committee, please help to navigate how we would like to take the pictures. Please make sure everyone join. Sebagian di atas panggung, Bapak Ibu, supaya terlihat. Please come to stage to some of you so that we can see everyone. And please committee to take screenshot so that we can have a documentation or pictures of the participants online too. Thank you very much. That was great to have memorable pictures with all of you. Ladies and gentlemen, to have a little refreshment, we would like to have a coffee break. And since we have a little delay at the beginning, we would like to ask all of you to return to our plenary room by 9:35. By 9:35. So coffee break time is 10 minutes and you can enjoy the refreshment outside of this room, just in front of this room. Once again, 25, yeah, sorry. 35. 35 kan? Okay, I would like to repeat. Now we will have a refreshment for around 15 minutes. And we would like to invite everyone to come back to this room by 9:35 so that we can start the keynote session. Please enjoy the coffee, tea, and everything we have here.
Innovation is the guiding vision that drives us towards the future. We cannot face this alone. We must stand together to make our vision a reality. Growing strong upon the land of Nusantara, a magical place filled with miracle and wonder. A land spanning 2 continents and 2 oceans, rich in culture and biodiversity. We and Indonesia are the necessary combination to realize the grand visions of the future. Like an orchestra, BRIN harmonizes research, development, assessment, application, and also synergies, invention, and innovation in Indonesia. We created an ecosystem consisting of 7 deputies, 12 research organizations, and 85 research centers dispersed throughout Indonesia. Research Organization for Aeronautics and Space, Research Organization for Nuclear Energy, Research Organization for Energy and Manufacture, Research Organization for Earth Sciences and Maritime, Research Organization for Life Sciences and Environment, Research Organization for Electronics and Informatics, Research Organization for Social Sciences and Humanities, Research Organization for Archaeology, Language, and Literature, Research Organization for Health, Research Organization for Nanotechnology and Material, Research Organization for Agriculture and Food, Research Organization for Governance, Economy and Community Welfare. BRIN catalyzing research and innovation to develop an advanced scientific ecosystem in Indonesia with two main targets. BRIN realizes the tremendous potential of the nation's youth in the field of science and technology. Thus, various research and innovation policies are being formulated to develop and cultivate human resources with high competence and aptitude in science and technology. Creating many excellent programs is a form of BRIN's commitment to researchers, innovators, and the general population from various disciplines across the nation. The research and innovation ecosystem quality improvement in Indonesia is also realized through the collaboration of various ministries, institutions, domestic industries, and regional governments, to name a few, by forming the Regional Research and Innovation Agency, or RIDA. Moreover, cooperation with various foreign research institutions continue to be developed through active participation as member of various organizations and international forums. BRIN organizes research into a more effective and efficient process by integrating human resources, infrastructure, and budget from various research and development institutions. Oriented by a national research priority, BRIN routinely enacts comprehensive evaluations from various research and development institutions. This effort is supported through the continued management and improvement of various research and innovation facilities located across 17 regions of Indonesia, dedicated towards the development of science and technology. BRIN continues to improve our contribution to research and innovation towards national development by developing and
To our
revitalizing
offline
4
participants,
areas of
you
science
can
and
also
technology,
visit the exhibition spot.
KST,
We have some booths over there that
an
I believe
integrated
must be
area
very interesting.
consisting of research
And you may get
laboratory
some
facilities,
information.
testing
So
laboratories,
please also
and
visit
industrial
the exhibition
facilities
booth.
for
Thank you.
both startups and SMEs, tenant office rooms, co-working space, meeting rooms,
The exhibition booths
gallery rooms,
are from PT Pertamina
and
Persero
other
and
supporting
Paragon
facilities.
Corporation, two of our generous sponsors. Please enjoy.
BRIN is here to manifest the future of a golden Indonesia 2045 by consolidating science and technology resources and creating a resource ecosystem and research-based economical foundation. Transforming Indonesia as a global reference in the development and application of science and technology, practices, and the good of humankind. Nature is the source of inspiration. Knowledge is the foundation, and to be put in praxis for the sake of the nation.
Energi bukanlah hanya sebuah reaksi.
Dia selalu ada dimanapun itu,
Membawa yang baik menjadi hebat.
setinggi apa kamu bisa melompat.
Jawabannya, setinggi apa yang kamu ingin gapai?
Karena tidak ada lagi batas. Kemanapun lintasan masa membawa,
Harapan, hati, dan mata yang berkelana. Dari masa kini hingga ke masa depan.
Yang sebentar lagi bisa kamu genggam.
Sejauh mana kamu bisa bermimpi?
Jawabannya, sejauh yang hati kamu inginkan.
Dengan energi yang menggerakkan kamu,
Dan kamu. Pertamina, energizing you.
Dari sebuah kepercayaan, kami berhasil wujudkan banyak mimpi besar. Namun perjuangan kami tak berhenti sampai di sini. Gagal, jatuh, penuh tantangan. Tapi kami tak pernah hilang semangat. Dengan terus berinovasi untuk hasilkan produk terbaik dengan sepenuh hati. Berkolaborasi, berkreasi tanpa batas, mengembangkan potensi, menjadi cara kami untuk terus berlari. Sejak tahun 2019, kami bertransformasi menjadi Paragon Corp, yang terdiri dari Paragon Technology and Innovation, perusahaan lokal kosmetik terbesar se-Indonesia, serta Parama Global ICSEEA sebagai perusahaan distribusi. Kami memiliki 41 distribution center, lebih dari 10.000 Paragonian, dan kami akan terus berkembang. Dengan R&D center terbesar se-Indonesia, kami terus berinovasi menghasilkan brand-brand terbaik. Visi kami adalah memberikan kebermanfaatan yang lebih besar berdasarkan 4 pilar demi membantu sesama untuk kemajuan Indonesia. Mari berbagi mimpi yang sama untuk terus bertumbuh, berkolaborasi, mengembangkan potensi bersama Paragon Corp.
Mitratel, as a telecommunications infrastructure provider since 2008, has managed more than 36,000 telecommunications towers spread throughout Indonesia. Our vision to become the #1 digital infrastructure company in APAC market drives us to continue moving to create a sustainable impact on the Indonesian people and nation. In the future, Mitratel will continue to innovate and be committed to serving Indonesia because we believe that new ideas can make Indonesia a better place. There is still a long way to go and challenges still lie ahead. Together with Mitratel, building hope into the future.
Masa depan dimulai di sini oleh mereka, putra-putri terbaik bangsa, mendedikasikan diri meraih cita, membuka harapan, menggali potensi untuk menghasilkan sumber energi. Energi yang baik, energi berkelanjutan demi masa depan generasi mendatang. Dengan lebih dari 120 gunung berapi aktif, Indonesia menyimpan 40% cadangan panas bumi di dunia. Panas bumi, energi terbarukan dengan emisi karbon yang rendah, menjadi salah satu solusi dalam menangani krisis iklim dunia. Panas bumi sebagai sumber energi listrik dihasilkan dengan memanfaatkan inti bumi untuk memanaskan embung air serta menghasilkan uap. Uap yang tercipta diekstrasi melalui jaringan pipa dan diarahkan ke pembangkit, di mana energi termal dari uap diubah menjadi energi mekanik dengan memutar turbin. Putaran turbin tersebut yang akhirnya menghasilkan energi listrik. Seperti prinsip pemanasan air dalam ceret, sisa uap air yang telah didinginkan, dikondensasi, dan berubah menjadi air untuk dimasukkan kembali ke dalam bumi, dan kembali dilakukan pemanasan secara alami. Proses inilah yang memastikan pembangkit listrik tenaga panas bumi sebagai pembangkit energi terbarukan yang berkelanjutan. Untuk melestarikan alam, uap yang telah digunakan untuk menggerakkan turbin diarahkan ke kondensor, sehingga uap tersebut terkondensasi menjadi udara. Air ini kemudian didaur ulang menjadi uap lagi secara alami. Geodipa didirikan pada tahun 2002 sebagai perusahaan patungan antara Pertamina dan PLN yang berfokus pada pengelolaan lapangan panas bumi di Dieng, Jawa Tengah dan Patuha, Jawa Barat. Geodipa resmi ditetapkan sebagai BUMN pada tahun 2011 yang pengawasannya berada di bawah Kementerian Keuangan dan PT PLN Persero. Dieng dan Patuha memiliki total potensi energi panas bumi masing-masing 400 MW dan sudah memiliki perjanjian jual beli listrik dengan PLN yang dituangkan dalam bentuk Energy Sales Contract. Geodipa Energi selalu berinovasi dalam setiap pekerjaan dengan memaksimalkan sumber daya manusia serta kemajuan teknologi dan digital. Terbukti dengan Geodipa yang ditunjuk sebagai implementing agency oleh pemerintah dalam eksplorasi di wilayah timur Indonesia yaitu Waisano, Jailolo, Nage, dan Bituang. Percaya, kami fokus pada keberlanjutan dan pertumbuhan yang cepat dalam mencapai bisnis. Menjadi perusahaan yang mengoptimalkan produktivitas dengan budaya kerja profesional dan mengedepankan keselamatan kerja. Menjadi yang terbaik guna mendukung program nasional dalam penyediaan energi yang aman dan ramah lingkungan. Geodipa membantu pemerintah dalam penyerapan tenaga kerja dan pengembangan masyarakat di sekitar wilayah kerja perusahaan. Hal ini diimplementasikan dalam bentuk 4 pilar tanggung jawab sosial kepada masyarakat, yaitu Geodipa Peduli, Geodipa Maju, Geodipa Pintar, Geodipa Hijau, Geodipa Percaya keseimbangan antara energi, alam, dan manusia di dalamnya adalah masa depan untuk kehidupan yang lebih baik. Geodipa Energi menghadirkan energi untuk kehidupan yang lebih baik. Seiring dengan perkembangan dan kemajuan teknologi, pertumbuhan ekonomi yang terus tumbuh membawa konsekuensi meningkatnya kebutuhan energi listrik. Guna mendukung pembangunan di sektor ketenaga listrikan dan rencana usaha penyediaan tenaga listrik di Indonesia, serta mendukung pembangunan pembangkit listrik 35.000 MW. Sebagai salah satu anak perusahaan PT PLN Persero, PT Prima Layanan Nasional Engineering atau biasa disebut PLN Engineering merupakan perusahaan konsultan jasa engineering terkemuka di Indonesia di sektor ketenaga listrikan dan telah berdiri sejak 3 Oktober 2002, memiliki maksud dan tujuan menjalankan usaha bidang engineering, pengadaan dan konstruksi, menjalankan usaha bidang operasi dan pemeliharaan pembangkit, studi sistem kelistrikan, studi analisa mengenai dampak lingkungan atau AMDAL, jasa konsultasi engineering, informasi teknologi, pendidikan dan pelatihan, serta penelitian dan pengembangan. Dalam mengembangkan dan meningkatkan pelayanan di sektor ketenaga listrikan, PLN Engineering didukung oleh sumber daya manusia yang kompeten dan berpengalaman serta memiliki sertifikasi profesi di bidangnya dengan memegang erat tata nilai budaya perusahaan. Pelaksanaan visi, misi, dan tata nilai PLN Engineering termin jelas dalam moto perusahaan, Your Best Engineering Partner. Dalam mencapai sasaran strategis perusahaan agar berkembang secara berkelanjutan, PLN Engineering mengembangkan produk dan layanannya dalam beberapa bidang, yakni bidang perencanaan, meliputi feasibility study, survey, engineering design, procurement assistance, environmental impact assessment. Bidang konstruksi meliputi design review, construction supervision, factory inspection, QA, QC supervision. Bidang operasi meliputi operation and maintenance, optimization studies. Bidang-bidang lainnya meliputi technical studies and information technology.
On our planet of civilization, humans have stepped into the intelligent era. Ubiquitous connectivity, pervasive intelligence, technology builds a better world. Our efforts to build a green world never cease. Optimizes tracking angle with local plant terrain and weather condition. Capturing more solar energy and increasing yield by around 1%. Smart IV Curve Diagnosis 4.0 is compatible with shingled modules and supports inspection on mixed installation of PV modules in one stream. For one 100 megawatt PV plant, a thorough detection of all streams takes only 15 minutes. Smart Grid Connection algorithm supports PV plant to stably operate in all grid scenarios. Smart ESS enables integration between PV and energy storage system. Huawei AI-powered residential and C&I smart PV solution delivers optimal electricity cost and active safety. Active arcing protection, accurate detection, and quick shutdown. Reliable design without quick wear parts, ensuring solar inverter stable operation. Built-in nighttime PID recovery, securing solar module performance. Smart PV modules optimize power generation of each module, increasing energy yield by up to 30%. Module-level intelligent monitoring, enabling you to learn PV plant status in real time. Modular design ensures flexible capacity expansion and optimal investment. Dual power, battery ready for optimal electricity cost. Smart energy management reduces power consumption costs and makes clean power accessible to all.
adalah jantungnya Indonesia. Listrik ini fungsinya adalah memastikan bagaimana rakyat Indonesia bisa hidup lebih sejahtera. Dengan listrik, ini semua energi berjalan. Transformasi 4 tahun yang kita sudah lakukan sama-sama berhasil. Tepuk tangan buat kalian.
Saat ini merupakan sebuah babak baru dalam perjalanan kami, sebuah perubahan besar yang merefleksikan tentang perjuangan dan semangat baru dalam menghadapi tantangan era disruption of technology dan transisi energi. Kami berkomitmen akan terus meningkatkan keandalan untuk menjaga kestabilan pasokan listrik demi kepentingan masyarakat luas dan sebagai motor penggerak pertumbuhan ekonomi. Di setiap langkah perjalanan, kami mencatatkan momentum keberhasilan yang membentuk identitas perusahaan ini. Pencapaian dan penghargaan yang telah diraih akan menjadi pondasi dan akan terus kami akselerasi sebagai bekal untuk menerima kepercayaan yang lebih besar dari para pemangku kepentingan.
Ladies and gentlemen, we would like to start our next agenda. Please return to the junior ballroom 2. Welcome back. How was the coffee break? Have you tried the coffee? Because I didn't have a chance yet. I would like to try later because it smells so good. I would love to try. I hope it was good, and it was also a chance for you to enjoy a little chit chat and maybe also to get some information at the exhibition booth. It was very interesting, I believe. So here we arrive to our next agenda, the keynote session, where we will have 3 keynote speakers. Professor Heri Hermansyah, I believe Professor Heri already with us. And then we also have Professor G.M. Safiullah, and we will also have Professor Shabir Giwala, who will join online. And this session will be chaired by our moderator, Dr. Wijo Kongko. Before we start, let me introduce the short profile of Dr. Wijo. Dr. Wijo Kongko is the head of Research Center for Hydrodynamic Technology, Research Organization, Energy and Manufacture, BRIN. He obtained his doctoral degree in 2007 in Civil Engineering and Geodetic Science in Leibniz University, Hanover, Germany. And he obtained his Master of Engineering degree in Civil and Environment Engineering in Iwate University, Japan, and Bachelor of Engineering, Civil Engineering in University of Gajah Mada, Indonesia. He has published numbers of prestigious publications in the field of civil engineering. Please welcome Dr. Wijo Kongko.
Thank you, Mbak Novi, as a master of ceremony today. And I was assigned as a moderator replacing the moderator before, Pak Juk. So we pray for Pak Cuk Sawakila, yeah, because he's still in the hospital. And today we have three keynote speakers, as mentioned by MC. First, Prof. Heri Hermansyah, the Dean of Faculty of Engineering, University Indonesia. And the second presenters, Professor G.M. Safiullah. Please come. And I read, I almost mistaken Saifullah, but the right one is the Safiullah, means purity. Is that right? Yeah. Okay. So the third presenter online, Professor Shabir Hajiwala from Graduate School of Energy and Environment, Thailand. Is that already? Hello.
Good morning.
How are you there?
I'm here. Thank you.
Okay, thank you. It's already in the Zoom, so online. So we will have from 9:35 to in total till 11:20, and after that we have 25 for Q&A. So will be 35 minutes each for the presenters or the keynote speaker. First, Professor Heri got a doctoral degree of philosophy, Doctor of Philosophy from Tohoku University in 2006, and currently acting as a dean, Faculty of Engineering, University of Indonesia, till now, since 2022. And I think many experience here. So for not wasting the time, I think Pak Heri, please deliver the presentation. Yeah, and time stays yours, please.
Okay, thank you very much, Dr. Wijo. Yeah, my long time, dearest friend when we are study together in Tohoku University. Today, I would like to talk about the role of biomass energy toward the decarbonized society. This presentation also prepared by my team in Energy System Engineering and Institute of Energy Studies of Faculty of Engineering, Universitas Indonesia. The outline of this presentation will be started about the role of the biomass energy, and then bioenergy for green transport, biomass for green power, biomass for green industry, and biomass for carbon dioxide removal. How about the key strategies in decarbonized energy system? Total final energy consumption by energy carrier for 2050 from International Renewable Energy Agency 2023, we can obtain data that from 2019, 2030 until 2050, the renewable share in electricity is growing from 21% in 2019 and predicted to be increased about 30% electricity direct, and then the renewable share on the electricity will be 65%. And then in 2050, when the direct the electricity 51%, the share of the renewable in the electricity will be 90%. And then the role of bioenergy in decarbonized sector. The bioenergy theoretically can help decarbonize sector, representing about 50% of the global greenhouse gas emission. The global greenhouse gas emission per sector and bioenergy applicability in the sector of energy up to 40%, industry 23%, building 21%, and the transport up to 16%. The applicable of the bioenergy solution for this energy, there is a full, partial, and very limited. In case of energy only, is on heat and power from biogas, energy from waste, and then for industry, it's between heat and power from solid biofuel, combined heat and power from biogas. And then for building, this partial use, heat and power from municipal solid waste, combined heat and power from gasification. And for transport, the biomass are corresponding to jet fuels, biogasoline, biodiesel, and bioethanol. In case of global, next slide, global bioenergy trade in, next slide, please. Global bioenergy trade in major market in 2020, there is energy flow by export and import. Here, in energy trade, Canada, US export the energy, yeah. Europe import, Russia export, China import, yeah. And then Vietnam, Malaysia, Indonesia also export the energy. And estimated export volume of biodiesel from major producer between 2016 until 2020. Here, the red one from Indonesia, yellow from Malaysia, blue from Argentina, and dark blue from China. Yeah. And then next slide, the network of flexibility of technology in biomass related to energy conversion. The green arrow indicated the technology which are already applied in the market. Yellow arrow indicate technology which have been demonstrated technically. Red arrow indicate technology under development. So the biomass conversion from feedstock, we can divide it into wet biomass and dry biomass. And then from this feedstock, convert into intermediate. The intermediate limited spatial and temporal flexibility can be in the form of product of gas, biogas, and pyrolysis oil. And then here, during process into liquid fuels, methane, LNG, pellet chips, biocoal, stabilized oil as and then stored and transport in energy carrier, the hydrogen and carbon dioxide will be released. And the application of this product will be applied in chemical, transport, mobility, and flexible power and store heat. And this also release the carbon dioxide. Next slide. The pathway biomass utilization from feedstock, intermediate, energy carrier, and applications sector. The wet biomass usually not storable, but the dry biomass storable. In the intermediate, there is a limited spatial and temporal flexibility. And then in energy carrier, there is a storable, large spatial, and temporal flexibility. And in the application sectors, the variable demand profile consists of the many sectors such as chemical, transport, combined heat and power, heat, and also negative emission. Next, then we go to biomass for green transport. The renewable, next slide, the renewable share of the total final energy consumption in transport for the last 10 years between 2010 until 2020. 2010, the non-renewable energy still 97%. Yeah, and for almost the last 10 years until 2019-20 is almost not so different. Yeah. The biofuel renewable electricity between about 4% and the 10% of 4% for the renewable electricity. And then next, the global production of ethanol, biodiesel, hydrotreated vegetable oils, or hydroprocessed ester and fatty acid fuel, or we can call this SVO and SEFA as a renewable diesel. We can see here that the production of the ethanol, biodiesel, and renewable diesel in this profile for the last 10 years. The production of renewable diesel increased almost 66 times during the last 10 years. The biofuel are typically blended with petrol or diesel when used in road transport. Yeah. In Indonesia, the blend typically range from 5%, 7%, and ethanol 20. The India has target until E20. It means ethanol 20%. In Indonesia, there's a target B30, 35. The higher blend also are possible with existing ED95 and B100, which are typically used in heavy-duty transport with a modified diesel engine. Next slide. The transport final energy consumption and corresponding emission under the net zero scenario by 2050. Here, the planned energy scenario 2023 until 2050, the TFEC will increase from 4% until 19%. And then the CO2 emission is projected to be decreased from initially 4% and then will decrease up to 84% by this scenario. The 1.5-degree scenario since wide-scale electrification of transport sector energy consumption. And we can see in Indonesia also, for the last 2 years, the electrification of the in transport sector is increasing very quickly. Transport sector decarbonization will require scaling up the adoption of the renewable fuels, including sustainable biofuels, hydrogen, and synthetic fuels. Mitigating transport sector CO2 emission would require countries to adopt ambitious biofuel blending target, especially in this decade until ramp up of electricity vehicles. Next slide. The final energy consumption in transport by fuel and by transport type for net zero scenario by 2050, the light duty vehicle, the oil consumption will decrease and will be replaced by electricity, hydrogen, and then for heavy trucks, also the oil is decreased. In all sector, aviation and shipping, the oil consumption also projected to be decreased and then replaced by electricity and hydrogen. This will decrease the emission also. Next slide. The global production of the ethanol, biodiesel, and renewable diesel, the implementation regulation number in Ministry of Energy and Mineral Resources, the mandatory biodiesel blending program into diesel has reached about 30%, commonly referred as B30. The utilization of biodiesel in 2022 reached about 10 million KL and saved about more than 122 trillion. In 2022, a new biodiesel plant in Kalimantan with an installed capacity with 900 almost 1 million KL with an investment of 28 million is built. Next slide. Now, in Indonesia, also the renewable diesel, the sustainable aviation fuel, and bioethanol also produced. The Pertamina Green Refinery produced about 3,000 BPD of renewable diesel and 9,000 BPD of SAF. The carbon emission from aviation sector can be also reduced by 22,000 tons of carbon dioxide equivalent per year by using the production of the SAF. The Pertamina Pertamax Green 95 is the implementation of this strategy. The project itself of this Pertamax Green is reported is about 96 million KL in Java, and where the ethanol demand about almost 5,000 KL per year. Next slide, please. Now we will talk about the biomass for green electricity. Next slide. Okay, this slide. The global bioelectricity install capacity for the last 10 years is also growing. We can see the profile in Europe almost flat, slightly grow, but in Asia Latin America, North America is growing with more stiff. And in Asia, half of the consumption or install capacity is in China, about from 43% in Asia, the 23% is in China. The bioelectricity and bioheat increased by 90% and 70% respectively between the last 10 years. The installed biopower capacity reached an estimated about 149 gigawatt in 2022, or just over 4% of total renewable power capacity. The biopower capacity increased by 5% in 2022. one of its slowest rate of year-on-year growth in the last decade. Next slide. Share of the bioenergy in electricity generation by feedstock. Here, the International Renewable Energy Agency reported that the renewable electricity generation come from non-renewable hydropower, wind, solar panel, bioenergy. Yeah, and most of the sources still come from non-renewable. In case of the bioelectricity generation, the sources come from bagasse, renewable municipal waste, other solid biofuel, liquid biofuel, and biogas. Next slide. The power generation mix and install capacity by energy source under net zero scenario by 2050. Here, the renewable energy share is projected to be increased from 37% up to 80% by planned energy scenario, and up to 94% by 1.5 degree scenario. So all power sector component must combine to deliver an effective, reliable, highly renewable, and decarbonized power system. Next slide. The technology biomass green power usually typically consists of direct co-firing, whereby biomass and coal are fed into a boiler with share or spared burners. The second type is indirect co-firing, whereby the solid biomass is converted into a fuel gas that is burned together with the coal. And then spared co-firing, whereby the biomass is burned in a spared boiler and steam is supplied to the coal-fired power plant. The biomass classification, here in the right hand, yeah, there's from biomass, there's treatment, biodigester, and become biogas, and from municipal waste or other solid fuel. So there is several source, several type from solid, liquid, and gas, and then used to for the power electricity generating in power plant, and then produce the electricity. Next slide. In Indonesia, the green electricity current status by co-firing in Kalimantan, Sulawesi, Maluku, Papua, Sumatra, Jawa, and Nusa Tenggara. The PLN implementing co-firing technology in about 43 PLTU with electric production of 1 terawatt, and emission reduction is about 1.5 million ton CO2 equivalent. So it's very significant. Not we can call this significant, but the reduction is number here, 1.5 million tons. By the end of 2023, a hybrid power plant where 100% of biomass operate by 50 days a month of PLTU in Sintang, West Kalimantan. Here the new and renewable energy from air and then geothermal, other renewable energy with the co-firing, with decomposition. Next slide, please. Indonesia green electricity for biomass green power. For example, Indonesia has biomass power plant with total capacity of almost 50 megawatt from 20 power plants spread across Sumatra and Kalimantan. Next slide. Then we will talk about the biomass for green industrial. The renewable share of the total final energy consumption in industry for the last 10 years, this slightly growing from 20% to 60%. The renewable electricity and modern bioenergy consists about 8%. Next. The transfer final energy consumption and corresponding emission under net zero scenario by 2050, the renewable energy share by planned energy scenario will be increased from 20% up to 22%. By 150-degree scenario will be increased up to 72%. Based on data from International Renewable Energy Agency. The five pillars reduce demand and improve energy and material efficiency along with circular economy practices and direct use of renewable heat and biomass, including solar thermal, geothermal, biofuel, and biofeedstock, indirect use of clean electricity by synthetic fuel and feedstock, also using renewable electricity. The use of CO2 removal and carbon storage measure including bioenergy for carbon capture and storage. Next. Opportunity of bioenergy for industrial decarbonization, the biomass to provide heat for industry. The biomass also feedstock for chemical and petrochemical industry. Next slide, please. This is biomass for heat processing from biomass into industrial and then resulting heat and electric. Next slide. And also from biomass can provide platform chemicals and material. From lignin-rich biomass can produce high chemical or bioprocessing by sulfolysis in ethanol, hydrothermal to produce low functional aromatics, phenolic compound, and then from microalgae also by hydrothermal can produce lipid protein including biocrude. And from fundamental reaction in sewage sludge or by hydrothermal also can produce carbohydrate, protein, and lipid as reported by Mori last year. So the biomass-based biomass and from biomass, bio-PE, bio-PP, bio-PU, bio-PA, biopolyethylene, biopolypropylene, biopolyurethane, biopolyamide, and then several bioplastic, polylactic acid, polyhydroxyalkanoate, starch-based, cellulose-based. So this will also growing beside the current petroleum-based.
Prof. Heidi, 2 minutes more.
Okay. And next, the Indonesia Green Industrial Status co-firing in CPO industry. Next, the biomass for carbon dioxide removal. The carbon dioxide removal, there is several strategy from natural climate solution. So here we restore and manage. And then by hybrid or biomass with carbon removal storage, by biochar and bioenergy carbon capture storage, and also by direct access for carbon capture and storage by engineered solution. Next slide, please. The role of bioenergy for carbon capture storage for decarbonized strategy, there is several scenario, 15% degree scenario in the left-hand side, and the role of total cumulative CO2 removal predicted from 2021 until 2050 will be minus 126 gigatons CO2 per year for the decarbonized strategy by using renewable energy conservation, electrification in end-use sector, hydrogen and derivative. Next slide. Next slide. Okay, so now the final is there's some strategy for a net zero economy. We can build an abundant, affordable, zero carbon electricity, complemented by clean hydrogen, sustainable sources. Biomass can also play a role, and its value is to be highest in material and chemical green biofuel and in application. To support this enhanced role for bioenergy, biomass supply will need to increase posting an urgent need for sustainability governance and practices. Improving the sustainability of the bioenergy supply chain and minimizing the negative impact are the priority for all bioenergy policy making. The main required development are reduction in the traditional use of biomass and increase in modern bioenergy used to heat building, more bioenergy use in industry, and biofuel for transport, road, aviation, and shipping. A strong growth in the use biomass for non-energy purpose, especially to replace fossil fuel feedstock for chemical production, is also needed. Although there is more direct use of solid biomass as a fuel to produce heat, there is also a stronger growth in bioenergy heat produce. Last slide. Here I would like to introduce that in Faculty of Engineering, we have magister program for interdiscipline. This not also for engineering, but also open for other discipline. For energy system engineering, we and maybe from BRIN also can join this program, this master program. Yeah. We have about 120 students from PLN last year for this program. Thank you very much.
Thank you, Prof. Harry, for the offer and the presentation, the role of biomass energy toward decarbonized society, and full of data we have already seen. And keep the question, take a note, and there is a session later on after 3 presenter or keynote speaker delivered. And the second keynote speaker, Professor G.M. Safiullah, with the wait a minute, the title of his presentation about the renewable energy based microgrids for regional and remote community. Please, yeah, time and stage is yours.
Assalamu alaikum.
Wa alaikum salam.
Honorable Chair, distinguished guests, and speakers, good morning. First of all, I would like to thank to the organizer for giving me this opportunity to present my research and also learn from you, your research, your project, and your experience. So I believe that I will learn many things from you in the next 2 days. So if you give me permission, can I move over there? Thank you very much. Is that okay for purpose? Okay, thank you very much. So thank you very much for introducing me, and Associate Professor G.M. Safiullah. I'm from Murdoch University, Western Australia. So I'm going to tell you about my research or our research in School of Engineering at Murdoch University on the area of microgrid, and that is for regional and remote community. On another sense, we can say that it is an off-grid microgrid. So from the previous keynote speaker, we learned a lot of things about what is going on, what is the energy transition is, what we are looking for. And especially we learn about different types of energy sources, especially renewable energy sources that play a key role for our community and for our economic. So especially we learn about biomass as well, that what the role biomass is playing as well. Okay. Okay. So I think, first of all, I'm GM Shafil and sorry. So I did my bachelor from Chittagong University of Engineering Technology. This is in Bangladesh. Then I was system administrator in a research organization in Bangladesh. And then I moved to Central Queensland University to do my master's as a permanent resident. And I did my PhD. And after that, I worked at Deakin University, Australia for a couple of years as a postdoctoral research fellow. Then from 2015, I'm at Murdoch University. So I moved from lecturer to this position. And currently, I'm the Associate Dean Learning and Teaching of Murdoch University. So then a brief outline of the presentation. So first of all, I'll give a briefing about what we are doing at Murdoch University, especially in the School of Engineering and Energy. And then we'll talk about what is the challenges in power system, especially. So energy and climate change is a very broad area, but I'm going to focus more on the power systems as a future engineer and also power sector operator, what we can do for that. And what is the motivation for my research or to discuss about microgrids on a remote and regional community. So then we will discuss about some of the research we have done and also some of the findings I'm going to share with you that may be useful or may be very aligned with Indonesian climate and Indonesian scenario as well. So that is and also we all discuss at the end, what is our current collaboration with Indonesia? We are working with Indonesia many, many years now, including BRIN. So I visited BRIN in 2000, the name was BPPT in 2016. I think I visited the microgrid center over there. So this is the presentation outline of this presentation. And first of all, what are the research area that we are involved in? So first of all, as an electrical power engineer, so electrical power system is one of the core area that we are dealing with. We are dealing with microgrid, we are dealing with the smart grid, we are dealing with power system stability and future electricity network, how the energy transition is going forward. And we are going with renewable energy systems and grid, and also how we can integrate more and more renewable energy into the grid. And what will be the challenges? What will be the consequences if we want to integrate renewable energy into the grid? There are many, many issues. There are very, very good thing of renewable energy, but there are a lot of challenges as well. One of this intermittent generation, like you are getting solar at this moment, maybe after 5 minutes, you are not getting any solar. So how we can manage the grid, how we can manage the power system. So this is the challenge we will discuss. We will discuss about the energy sources like solar, PV, and wind. So we learn from biomass. We will learn a bit from solar, PV, and wind through this presentation as well. And hydrogen and energy storage play a key role nowadays to accommodate some of the challenges introduced by the renewable energy or the intermittent generation of renewable energy. So basically, these are the things we will also discuss about work on energy sustainability or sustainable development goals. We are working on the energy transition, energy policy, regulation, and so on. So this is more about our research areas. So this is one of the research area that I'm dealing with and I'm leading, that is the smart power and renewable energy systems. So we have a research group, and this research group is working with me, including few academics and also PhD student and postdoctoral research fellow. So on that, we are working with microgrid, and smart grid, and future electricity network. So what will be the future? What we need to do in the near future to accommodate the challenges introduced by the renewable energy. And we are dealing with standalone power system for remote community. And we are dealing with grid connected and off-grid power systems. And also we are also thinking about the intelligent short-term solar forecasting. So all these are aligned with this group. And also we are working with the energy transition and sustainable development. And as we mentioned, that what will be the future, what we need to do for the future, and what will be what we are working with the utility and the government to go for energy planning, energy system modeling, framework for decarbonization of transport, and decarbonization pathways for the future. So all this is included in this energy sustainability and also research collaboration with the industries nationally and globally with the government as well. So this is the major area of research. But what drives me to come to this point? Why we are considering on the renewable energy and also the microgrid and so on. So Australia government has the net zero emission by 2050. So there are many sectors we need to concentrate to meet this target of net zero emission by 2050. But as a power engineer or as an electrical engineer or as an energy specialist, what we can do for our perspective. So that is my target, to concentrate on this area. We cannot concentrate all this area that is needed, but we can concentrate or focus on a specific area. So this is my area that we are considering. So what is the challenges? One of the major challenges is the global warming. So greenhouse gas emissions. So we need to reduce greenhouse gas emissions as much as possible. So what we can do? And also we have the power quality issues, energy crisis, that is everywhere. Maybe Australia, it is less compared to many other developing countries or many other countries, but everywhere there is an issue. And also remoteness is another issue for Australia, like many areas, like I think Indonesia has many islands as well. So they have remoteness and they are not connected with the main grid. So that is the issue, that is the challenges of power system now. So what is the solution? One of these solution is to integrate renewable energy that is climate friendly, no emission, and abundant, available everywhere. You just need to harvest it. You just need to harvest it. No need to do anything. So that is one of the issue that we need to, but as I mentioned, that renewable energy has some challenge, that is the intermittent generation. So we need to come up with intelligent optimization and monitoring system, and also smart infrastructure, smarter technology that we call now microgrid or smart grid. That's not working. Next slide, please. Okay, so this is Australia and Western Australia. So you can see that this is the part of Western Australia is grid connected. But this part, all this part is not grid connected. They are not connected with the central grid. So this, sorry. Okay, sorry. So this is the part, they called it Southwest Interconnected System. And this is dark blue. This part is only grid connected system. But the other part of Western Australia is not connected with grid. All are isolated, an individual network in different cities and so on. So this makes that city a remote city from the Perth city. So this is the part that is within Perth and some other cities nearby. But this is, especially this is more on the mining region and bring the economy for Western Australia and Australia. This is the Pilbara Port Hedland region. So all this is remote community and they have run by diesel generator mostly. Nowadays, in the last 10, 15 years, they are trying to move it to isolated and integrated microgrid with renewable energy integration. So now they are calling it off-grid, microgrid, or mini-grid system. And they all are isolated and they have mostly with diesel generator. Now they are trying to introduce solar on that. And there are a lot of works is going on to make these things happen. So this is basically one of the issue is the diesel transport cost is one of the big issue in addition to the greenhouse gas or the global warming. Because transport from the fuel from here to this location is very expensive. Not only the fuel price, transport cost is one of the. So now they are trying to get rid of this diesel generator and trying to install more and more renewable energy, especially solar. Solar is very, very promising over there because of the sunshine and so on. So, but as I mentioned, that what is the challenges? This is the challenges. we have intermittent generation, fluctuating generation. So we supposed to get a wave shape from the solar like this, but we are getting this. So we need to prepare for this, how we are going to tackle this issue. So that is basically drives me to do this work. And so what is the solution? One of the solution is we need a energy storage system. So this is one of the snapshot of the research that we are going with one of the Australian regional energy network with and Horizon Power. Horizon Power is the utility. Basically, they are dealing with all the remote community. So you can see that with the time, how the solar generation is fluctuating. So there is a cloud across the, and due to this cloud, the solar generation is changing. So the standard wave shape is changing, and the generation is, you can see this is the generation and how these are going to fluctuate with this cloud movement. You see, we are almost has gone, okay? So then this is the challenge and this is the solution, possible solution. So what we need to do, first of all, we can start from house. We can apply demand response or demand side management to accommodate or change our behavior of appliances uses, like reduce the peak time uses, shift your uses from peak time to off-peak time. So that is the demand response that we can do by ourselves at a house owner or a industry people. And then we need to increase the renewable energy penetration. And then what we can do, we know this is the problem. So we come to this point that finally, if we want to self-sufficient with 100% renewable energy options, we need to, we need to go for a renewable energy storage system. So we need to integrate some sort of energy storage that we can store energy when there is not enough demand. So like sunshine at 12 p.m., that is maximum solar energy we are getting from if there is a solar energy there or something. And that time, maybe our demand is not that much. So if we can store that energy and we can use it when there will be a issue with interruption or at night when solar energy is not there. So that is the solution. Basically, the research community and industry and utility everywhere is thinking of this renewable energy storage will be one of the solution. So different types of storage is available. We know everyone that different batteries, different types of batteries as well, like lithium ion, lead acid, bulk flow battery, and then we have pumped hydro flywheels, hydrogen, heat energy storage, supermagnetic, and so on. So then different types of energy, and different types of energy has different types of features. Like they have advantage. They have advantage with some sort of has charging time, low charging time. Some have more charging time. Cost is another big problem as well. Like battery is very cheaper nowadays, but hydrogen, if we go for hydrogen, it is costly. And there are some other issue with the safety and security as well. So considering that we need to choose energy storage, we need to choose the energy resources like wind, solar, biomass, geothermal, whatever, based on the availability. So if I say Western Australia, solar is the most convenient one as it has available. But maybe it is different for Indonesia or some other island, or maybe coastal area, we can go for hydro even. So there are many types of energy resources, many types of energy storage available. So we need to go for which one is most convenient to us based on the economic viability, based on the technical viability. So that's the conclusion here. Now I'm going to go with some research on microgrid. So especially in the area of remote microgrid. So this is one of the research that one of our PhD student who is currently working with one of the utility company in Western Australia. So this is innovative control strategy for microgrid. So this is the island and microgrid, and it has the issue with fluctuating generation. So how we are controlling that through this control system. So considering that so we have considered the operational flexibility, we have considering the renewable flexibility, we have considered the technical flexibility, and we have considered the renewable environmental flexibility. Considering all this operational flexibility, we have designed this microgrid. So in this objective function, we have considered all aspects of that, and then we consider this microgrid. So it has renewable energy generation, it has battery energy storage, and so on. And we've found that technically it is possible with this control system to manage a remote community microgrid. So this is a standalone and remote community microgrid. In the next slide, what we do with another PhD student. Next one. Okay, so now so in the last one, we have used one microgrid only. So what we are doing here, we are connecting multiple microgrid here. So maybe in one city, there is one microgrid. There is an adjacent city, there is another microgrid. So this microgrid A, has more generation than demand. Other microgrid has the opposite situation. They have less generation, but more demand. So if we can connect two microgrid, they can exchange power between them. Okay, so this is the microgrid, basically what we are trying here, to connect multiple microgrid and exchange load between them, exchange power between them to make more sustainable operation. So we consider cost, we consider technical aspects. And we also use 3 types of topology in connecting microgrids. So there are 3-phase, single phase, and DC. So we think that DC will be from the analysis, we found that DC is comparatively better in regards to autonomy and cost compared to 3-phase and single-phase system. So now from the technical point of view, now we will go to see the economics of this system for a microgrid. So this is one of the research that we did, and all the research is published, is available online. Like if you want, you can have a quick look on that later on. So this is one of the research on Bangladesh. So it is a island and microgrid as well. So we see the economics of this microgrid, how it is economically viable. What are the options? What type of option we should go to make it economical or cost effective? And we will consider here commercial load, residential load, as well irrigation load for them, because Bangladesh irrigation country and so on, they need to. And we will go with some sort of mechanism for that. This is a case study, is one of the island in Maldives. So this is also published, and we have considered how this system can be efficient for that island. And we found that it is economically viable with the considering the lead acid battery and also some other sort of battery, I mean with the energy storage system. Like this is a completely 100% renewable energy. So we also see how we are going to replace all the diesel generators. So at the existing point, they have all running with diesel generator. And we see that how it will be economically viable to put wind, and we have also calculated the area available to install solar PV on that location, because this is island and a very limited area to install solar. So that is, we have investigated as well. This is one of the case study for Australia, basically. This is one of the island that we have considered how we can generate off-grid microgrids on that. Because we come to the point that technically it is viable. Now we need to come to the point that economically is it viable or not. So economically, like when we did this research in 2017, it was okay, but now it is economically fantastic because the price of solar, price of battery reduced every day basically. So then this is a grid connected system, and we, in this case, we have done a rigorous analysis considering off-grid and grid connected, and we consider the not only economic analysis, we have considered what type of algorithm we need to use to generate the forecasting technology for the solar and wind. And also we organize a dispersed methodology for this, so that which dispersed methodology will be useful to generate power to and deliver power to the community. Then with this techno-economic analysis, we integrated the sustainability indicator, that the more efficient and integrated sustainable indicator for energy sector is the SDG 7, that is the energy. And this, how we can integrate this. So this is our So this is our hybrid renewable energy system, and this is the remote community where we are putting electricity, and how this can be affordable and sustainable electricity for the community, so that we have indicated and identified. Finally, recently we did a job with a project with agrivoltaic systems. So you know that like Bangladesh is one of the agriculture country, and many lands are just wasted due to the solar panel when we produce. So we are trying to organize a system. Oh, sorry. Okay, so we are trying to develop a system that is the land is not wasted, so we can produce crops under the panel as well. So that is the way we will increase the height, and we will increase the structure of the panel, that it will not affect it on the regular crop production. So this is the economic analysis. So this is the system. We have considered different types of generation system and different types of crops. And also we considered the grid connection, then the easy bike and the solar pump and so on. Considering all this, this is our economic model. And this is available online as well. And and we found that this is economically viable, and still the cost of installation is more, but as we getting crops and we are getting revenue from crops, that is not economically bad. Now I'll tell you a bit about the project that we have done in the area of microgrid. So this is one of the projects that we have done with one of the utility, that is the utility who are dealing the off-grid network that I showed after the Swiss boundary. So especially these are the area. This is the Horizon Power is the utility who are dealing this. So we have done a project with them for a location in Carnarvon. So it is like here somewhere. And sorry, this one. So this is the Carnarvon, and we did a analysis. So it is funded by Australian Renewable Energy Network, and it was a nearly $7 million project. And we have identified that what is the solution for that community. So Carnarvon is a city of 500,000. So 10 years back, all the energy generated by diesel generator or gas turbine, now they are trying to go for 100% renewable energy or solar energy. So this is as a test bed. This is one of the project that we have done. And through this project, basically we have installed this solar system with the battery and also the monitoring and control system to 50 customers to see how we can address their problem. So then we also, with this system, we also apply a short-term forecasting system. So DLR Germany is also involved with us with this project. So Horizon Power, Murdoch University, and DLR Germany. And we have short-term forecasting. Maybe you have heard of Sky Camera. So you have installed a Sky Camera and collecting the data, real-time data, and putting it to the control center that, okay, this is the next minute where the forecasting is coming. So there will be no solar in the next 3 minutes. Act on accordingly, and the control system will turn on the generator or some other devices who will replace or the battery or so on. So this is one of the projects that we have completed in 2023. Okay, so the next project that we just completed last year as well. This is one of the projects funded by state government of Western Australia to see how hydrogen play a key role with PV battery system. So this is one of the location in the northern region of Western Australia, Pilbara. This is the mining zone of Western Australia or even Australia. So this is the project basically we have done through government funding. So this we have investigated that 100% renewable energy based solution how can be a good option for Pilbara. So through this project we have selected 2 locations and we have identified the knowledge sharing. We have generated knowledge sharing report and also identify how Western Australia can roll out this approach in the next 10 years. So all these details are here. I will give you how many minutes I have. So this is the 2 locations that we have selected. So it is Pilbara region. So Port Hedland is one of the port in Western Australia. So Jinpirinea is one of the community and Warralang is one of the communities. So Jinpirinea is a very small scale community that with only 7 houses and currently they have a grid connected system. So we are trying to see how this grid connected means diesel generator is supplying the electricity over there and how this can be effective with a 100% renewable energy system. Then Warralang is a community that currently running with 3 diesel generator and it has I think 30 houses and school and community. So this is the 2 community, as I mentioned, that is, it is 7 houses and it has 35 houses and a community center and a school. And the total 158 kilowatt hour per day. And here it is 1385 kilowatt hour per day. So we have investigated techno-economic analysis considering these aspects. So reduce emission and dependence on fossil fuels, one of the, and we need to reduce the cost of energy. We need to go with 100% renewable energy with reliability and autonomy. And what we are trying to do, we are getting rid of this diesel generator, coming with 100% renewable energy resources. And also we will go with hydrogen and electrical load. And there is no fuel transport cost. That is one of the burden and 0 carbon emission instead of carbon emission. So this is that solution we are trying to do this. And this is the flow chart of the model that we have done. So initially we selected the data and collect that electrical load of this community from the utility and then select the renewable energy resources. Mostly we consider solar. And then we consider different types of battery, hydrogen and energy storage. And then we have go for the controller and converter for this location. So this is all this what we have done. And finally, we got the results for these 2 community. And we selected from the many option. We have selected 3 option, best option. And based on that, we have selected option 2 is our model where we get a bit of hydrogen, more hydrogen than other options. For the other community, we also have something like 3 options. So first option we have, this is the base case initially that is, and then we go connect with, we see that if we go with 100% renewable energy, that option W1 is a bit costly and not economically that much viable. But if we go with 1 diesel generator with hydrogen, that is more effective and cost effective and viable. So we are solve this option this one. So this is a bit of, so this is the scenario where the hydrogen based RES system works. So when there is a sunshine, you can see that electrolyzer is running and the hydrogen is storing and also giving support to the houses and residential area. Then this is when there is no sunshine. So energy is coming from hydrogen storage or the battery where it is possible. Then, so the key finding is we have find that there is no issue, there is no technical barriers to employ or deploy this type of renewable energy sources with hydrogen. And the motivation here, basically, when we develop a transition plan for the government to supply, we see that there are 140 regional community. They are Aboriginal community or indigenous community. They are kind of running with all with diesel generator. So we propose that this all diesel generator running utility system can be bring with 100% renewable energy and hydrogen. So based on that, basically, we have developed this knowledge sharing report, and it is available online. And this is our transition plan. So there is a 10 years transition plan we have given to the government. Initially is 5 years to start the rollout. So it is a 2023 to 2035, give a rollout plan to government, how you can go for that.
Prof. Safi, 1 minute.
Okay. Oh, now it is stuck even. Can you go to the next? Based on the techno-economic analysis, we built a hydrogen-enabled power system. So this is also funded by the government, and this system is ready to use now. So this is a hydrogen-enabled power system. And now we are also doing a water smart farms. So this is a for farmer. So we have water desalination system and solar battery system, and also the monitoring system integrated with that. So now what is the scenario that is Indonesia? Basically, there are a few more slides. It is about all Indonesian perspective. So in 2018, Makassar conference, it was related that there is a big alignment with Australia and Indonesia due to geographical region aspects or some other aspects of the community. But due to time, maybe I can go for very quick on that. So we have a lot of engagement with Indonesia, especially in the Marduk University. Some of you may know Associate Professor Martin Anda. So he is bringing and he's visiting many places in Indonesia and bringing a student. And we have a MOU with Marduk University and BRIN and some other university and organization. I'll go brief. I think you know Dr. Nugroho, one of the director, he's here. So, and also we have many collaboration with South Surrey and also some other university in Western Australia. We did the Australia Award, Indonesia Award, and we received that award, and 25 Indonesian delegates were presented on that, and we had a very good experience with that Australia Award Indonesia. This year we are going to apply for this as well. So Australia Award Indonesia, and we are planning to submit for that, and we will come to you soon on this. So this is one of the projects that currently we are doing with BRIN. So this is maybe last 2 to 3 slides. So this is the city climates investigation for Southeast Asian cities. So there are 4 cities we have targeted. One is the Jakarta, then Kuala Lumpur, Bangkok, and Manila. So this is the 4 cities we are investigating that is funded by the DFET, Department of Foreign Affairs and Trade, Australia. And there are 4, the Curtin University and Marduk University in Australia, and there are 4 research organizations in 4 countries. So we have recently presented the final outcome of this project. So and based on that, we have discussed with you, and then with the support of the national and the policymakers and the local council, we received feedback, and based on that, we will develop a climate action plan for Jakarta and also 3 other cities. So these are the few priority areas we have indicated on that. So I'm not presenting that due to time. Thank you very much. Thank you.
Thank you very much, Prof. Safi, for the presentation titled Renewable Energy-Based Microgrids for Regional and Remote Community. And there are some very interesting data, and I think the lesson learned from continental country like Australia And very interesting if we compare to Indonesia as well, because we have 17,000 island as an archipelago country, and half about 7,000 habitats. So that's a challenge, and yeah, very interesting. We discuss later on, and I'm apologize for not introducing you for the CV before, but I should add that Prof. Safi's achievement, he is listed as the top 2% of scientists worldwide from 2020 till 2023, yeah. So hat-trick. So this is announced by Stanford University for the 2% of scientists worldwide. So very outstanding he is, and thank you very much for the presentation. And again, please keep and note the question, because we have later on the time for the question and answer. So we move to the third presenter or keynote speaker, and I'd like to invite Professor Shabir H. Kiwala. He's in the Graduate School of Energy and Environment, Thailand. He is also the research interest about the sustainability assessment of the energy system, circular economy, certification issues, and so on. So the achievement, many more than 350 papers in the peer-reviewed journal, and the Scopus H index more than 50. More than 50 is a very high. So have you already in the online, Professor Shabir?
Yes, I'm very much there. Thank you very much for your kind
Thank you very
introduction.
much. And yeah, please know your time, and
thank you very much.
you're ready to have your presentation. Go ahead. Yeah.
Okay. So yes, thank you very much for your kind introduction. Good morning to everybody, and Assalamualaikum warahmatullahi wabarakatuh. So thanks.
Waalaikumsalam warahmatullah.
Thanks very much to Bryn for inviting me for giving this talk. And today I will talk about the life cycle thinking for renewable energy systems towards decarbonization. We already had two very excellent talks before this, so this will serve as a supplement to that. But what I will do is try to introduce the idea of life cycle thinking, why it is important. I've been studying this for the last 20-25 years, and I will share some results and mainly try to focus on some of the insights from what I have learned in the last 20-25 years regarding how life cycle thinking is essential to consider when evaluating any system, be it energy systems or others. But for today, we will focus more on energy systems. So energy and environment. We need energy. We can't do without energy. Yeah, so it is kind of a most basic need of ours. Along with food and shelter, energy is also a basic need. So when in the very old days, when we did not have civilization as we know it today, we were hunter-gatherers. That time, fire was our source of energy. And then in the agricultural society, before the Industrial Revolution, we had energy sources from livestock, like buffalo or something for doing the plowing of the fields, etc. Actually, we use it today even, but that was the source. And then we had windmills for irrigation and so on. But after we discovered coal and fossil fuels and we had the industrialization, so our energy mix changed. We had much more denser sources of energy, releasing us from a lot of the burdens that we needed from human labor or animal labor and for other activities, so that we could use these energy dense forms like coal, natural gas, oil, and so on. But energy is also associated with environmental impacts because we use non-renewable resources like coal and so on, natural gas and so on. And then there are also emissions of carbon dioxide, which is, as you know, a greenhouse gas, and many other gases such as sulfur dioxide, NOx, and so on, which have other impacts on the environment, for example, acidification, eutrophication, and so on. So there is this plus and minus associated with non-renewable sources of energy. Now, here I would like to just introduce this thing that our Earth has a capacity to deal with all this pollution. Earth has been existing for millions of years, yeah, or billions of years even. However, more recently, in the last 200-300 years, we have been facing many issues, yeah. And one of the big issues is greenhouse gases, yeah, or climate change or global warming, as we call it. But that is not the only thing. So there are other issues like ozone depletion, biodiversity loss, land use change, and so on, freshwater, many things are there. But a group of scientists many years ago, in 2009, actually, they got together and calculated what is the threshold, the boundary which the planet, our planet Earth, can take, and what is the safe limit which we should not exceed. So if we are below that limit, then we are doing fine and the Earth can take care of itself. But if we are beyond that limit, then the Earth's internal processes are unable to deal with that amount of waste. And I'm presenting you today what was the latest situation I have from 2023. So this, you see in this middle over here, there is the safe operating space in the dotted line, yeah? And if we are below that safe operating space, we are in the green zone. And beyond that, we are in the red zone, which is the dangerous zone. So they define 9 categories like climate change, novel entities, biodiversity, land use, and so on, as you can read on the slide. I will not go through all of them. But the point is that for 6 out of those 9 categories, we are already in the red zone, as you can see. Climate change, we are in the red zone. Biodiversity, we are in the red zone. Land use, we are in the red zone. Freshwater, we are in the red zone. Geochemical flows, we are in the red zone. Novel entities like plastics, etc., we are in the red zone. Now, what does this mean? 2 things. First of all, climate change is not the only important thing that we need to consider. Of course, it is very important. So when we talk about decarbonization, of course, that is why we are talking about decarbonization. But we cannot deal with climate change in isolation, because there are other impacts also to consider which are also important, which I'm showing over here, 9 of them. Yeah, and these impacts are interrelated. So if we focus only on climate change, and I will show you some example what happens. If we focus only on climate change, we may create problems on other impacts, which is not a smart thing. Yeah. So for example, we say, oh, let's promote biofuels to reduce greenhouse gas emissions. But when we promote biofuels, we have land use change. That is a problem. We need extra water for the biomass, to grow the biomass for the biofuel. So we have problem in fresh water. We put more fertilizers. So we have problems with biogeochemical flows, which is basically phosphorus and nitrogen flows, which are coming from fertilizers. When we put pesticides, etc., we have problem with biodiversity. You see, so trying to solve one problem, we have created 5 other problems. Yeah. So the point is that we have to look at all impacts together, not just focusing on one impact. Otherwise, we may shift the problem from one impact to another. While trying to solve one problem, we are creating 5 other problems. Yeah. So, and this is the idea about this so-called life cycle thinking. Yeah. I will show you illustrations of many studies. This is my favorite slide. I like to show it every time I make a presentation. So all of you can see that there is an elephant over here. Okay, there's an elephant in this room. But on this slide, you see 6 people who have blindfolds on their eyes. They cannot see this elephant. They are only feeling different parts of the elephant and making their interpretation based on what they feel. So the person who is sitting on top over here and feeling the big ear of the elephant thinks that it's a fan. The person who is feeling the side of the elephant, very big side, thinks, oh, it's a wall. Somebody thinks it's a spear, a snake, and so on. 6 different people with 6 different interpretations, but no one can see that there is an elephant. If we need to address the elephant in the room, we need to see that the elephant is there. And this is a very powerful metaphor for life cycle thinking. And to address this kind of thing, for the environmental part, at least, we have a tool called life cycle assessment. Yeah. So this life cycle assessment, what it does is it looks at all parts of the life cycle, which means starting from resource extraction and refining, manufacturing, packaging, use, end of life, etc. Why? Because we don't want to shift the burden from one part of the life cycle to another. That is very important. And I will show you what happens as a result of that. And we look at many impact categories, not just carbon footprint or decarbonization. Yeah. That is, of course, one thing to look at. But then water footprint, ecosystem quality, natural resources, human health, all these things need to be looked at together and try to solve the problem together, because we don't want to solve one problem by creating another one. Yeah, that is not so smart. Okay. So that is my introduction. And now I want to show you some examples. I will start with this natural gas. It's a very conventional production of energy. Yeah. And I choose natural gas because in Thailand, natural gas is one of the biggest sources of feedstock for the electricity. About 60% of the electricity in Thailand is coming from natural gas. Now, what I have done is showing you two types of natural gas power plants. One is a thermal one, which is the less efficient one, and the other one is the combined cycle one, which is the more efficient one. So the less efficient one is on the top, and that is the bigger bar, and the more efficient one is at the bottom, which is the smaller bar. Now, what I want to show you, I want to point out two things over here. One is that this, normally when we talk about fossil fuels, we think about what are the emissions from the combustion. And here we are looking at greenhouse gases. And we see that, of course, combustion is the most important. The light blue bar, the light blue part of the bar is the greenhouse from the combustion, and that is important. But the upstream, that is the production, the extraction of the gas, the cleaning of the gas, and so on, they are also contributing about 10%, which is not negligible. So that is also needed to be considered. Okay. Now, so this is for the non-renewable. I'm just using this as a proxy for non-renewable. What I would like you to remember now for the next 5 or 10 minutes is that from natural gas power production, the greenhouse gas emissions are around approximately 600 kilograms of carbon dioxide equivalents per megawatt hour of electricity. Okay, 600. Okay, please remember this number 600, because we will use this as a benchmark for comparing other renewable energies and see how they are doing as compared to electricity production from natural gas. Okay, 600. Now you see mini hydro. Mini hydro is one of the renewable energy sources. So mini hydro, the special thing about mini hydro is it is run of the river type. So there is no big dam. Big dams have their own big problems. And a lot of international organizations don't consider the big dams and electricity production from big dams as renewable, because there are so many problems associated with it. But mini hydro, micro hydro, run the river type hydro are usually accepted by everybody as renewable energy, because the impacts from the dam, they have very small dam, actually, very small one. So the impacts are not big from that. Now, a lot of times we tend to think that, oh, renewable energy means zero emissions or no greenhouse gas emissions. But that is not true. From the life cycle perspective, there are emissions, okay, because you have to construct the infrastructure and so on. So during the production of the electricity, when the water is running, you don't have emissions. That's true. But to construct the turbines and other penstock and so on, you still have emissions. So here you see that on average in Thailand, we have about 18 kilograms of CO2 equivalent per megawatt hour. Sometimes policymaker gets very angry because we say it is not zero. But it's a fact, it's not zero. It's about, but it's less than 20, you can see. Less than 20 kilograms of carbon dioxide equivalent per megawatt hour. And compared to, remember, 600 for natural gas. It is much, much lower than the 600 of the natural gas. So that means, even though it is not zero, but there is definitely an advantage from producing electricity using mini hydro. Okay, that was mini hydro. Let us look at solar. For solar PV, we have done studies for looking at the PV cells being produced in many different countries. So you see, the first two bars are from Germany. The next two, the blue ones are from Japan. The green ones are from China, and the orange ones are from Thailand. Okay, so China had relatively higher emissions because the production phase, they used coal-based electricity, so their emissions were higher, okay? But and there are two bars you can see for every country, and that is because we are looking at two types of PV. One is integrated with the roof, that is building integrated PV, and that has lower emissions because you are replacing part of the roof with the PV, so you gain advantages from the substitution of the roof material, okay? That is why those are lower. And when you don't have that substitution, then the emissions are slightly higher. So once again, you see that the emissions are not zero, but on average, for example, if we take the thing of Thailand, it is between 20 to 80 kilograms of CO2 equivalent per megawatt hour, which again is much lower than 600 for the natural gas. So with the PV also, we are doing better than the natural gas. Okay, not zero, but better than natural gas. And of course, much better than coal. The coal is much higher than natural gas. It's about 1,000 kilograms of CO2 equivalent per megawatt hour. When we look at wind turbines, okay, this study we did in Thailand once again. So there are many things in the wind turbine. You have many things to produce. You have turbine materials, you have steel, aluminum, glass fiber, copper, some rare earth materials. All those things need to be done. So you have the turbine, the inverter, the battery, all those things need to be produced. That is why when you actually run the turbine, there are no emissions. Yeah. But when you produce the turbine materials and you dispose them, then there are emissions. So that is why you get about 40 to 160 kilograms of CO2 equivalent per megawatt hour. Once again, not zero, but much lower than your 600 kilograms of CO2 equivalent per megawatt hour from the natural gas power production. Okay. So these are some of the renewable energy. We saw PV, we saw wind, we saw hydropower, okay, mini hydropower. Now I want to talk a little bit about biomass. So we already had discussion on biomass before, but now we will see from a life cycle perspective some things that you might not have otherwise noticed. Okay. So when we look at biomass, many times you will hear that people say biomass is carbon neutral. And the reason for saying that is because we say, oh, the carbon in the biomass is coming from carbon dioxide in the atmosphere during photosynthesis. So when we burn that carbon in the biofuel, yeah, to produce energy, then that same amount of carbon dioxide is again going out into the atmosphere. But we already got that trapped from the atmosphere itself during photosynthesis. So it's neutral, right? No, but we have to think about the elephant, yeah, the entire life cycle. So when we grow the biomass, we need to add fertilizers. Okay, producing the fertilizers, especially nitrogen fertilizers, are very energy intensive. That has very high emissions. Then applying the fertilizers, nitrogen fertilizers release nitrous oxide, which is a very strong greenhouse gas. Then the whole life cycle is there, biomass harvesting, conversion to biofuel, all these are having emissions. And so there are net actually greenhouse gas emissions from the biomass supply chain, and it is not carbon neutral. And in fact, if we step one step backward before the cultivation period, that is a land use change, there, if you convert forest to agricultural land, then the amount of carbon that is released from the stock in the soil and the above ground biomass of the forest, that is so huge that it is impossible to recover that in the lifetime of the biomass project, and we will never break even. So that is a no-no. If we convert forest to agricultural land for producing biomass feedstock, then we are not going to have advantages in terms of greenhouse gas emissions. Okay, so this is something to be avoided. I'm not saying biomass is bad, but what I'm saying is, if we want to maintain the benefits of biomass, we have to take these things into account. If we don't look at the entire life cycle and take these things into account, we will lose while we imagine that we are actually gaining. Okay, let's see some examples of what happens as a result of this. I will take a couple of examples to show you. Now I'm showing you the life cycle greenhouse gas emissions from ethanol. Ethanol is a fuel that is used to substitute gasoline. In Thailand, it is produced from two feedstocks, mainly cassava and from sugarcane molasses. Little bit is also produced directly from sugarcane juice, but I did not consider that here. Mainly from molasses and cassava. So on what I would like to focus you to focus on is this red dotted line. And that is the benchmark for the gasoline, which is about 90 grams of carbon dioxide equivalent per megajoule. Yeah. So if we are lower than 90, we are doing better than gasoline. If we are above 90, we are doing worse than gasoline. So here you can clearly see if you convert forest to cassava or forest to sugarcane, you see the emissions these two bars here, which I'm pointing, these are so high, they're much higher than 90. So there is no chance that we make any gain as we expected. Yeah. But even if we consider other like grassland to crop and so on, still the benefits are quite low. Yeah. So really we need to avoid land use change in case of this, if we want to have benefits from using the biofuel for reducing greenhouse gas emissions. This is a very, very powerful message. Okay, this was ethanol. Now let us look at biodiesel from palm oil. Okay, so in Thailand, like in Indonesia and many countries in the region, we use palm oil for biodiesel production. Now here we will use our benchmark for comparison as diesel, because the biodiesel from palm oil will replace diesel. Yeah, diesel is about 85 grams of carbon dioxide equivalent per megajoule. So here you see for the palm oil, even when we are having some slight land use change, we are still having the values. All these bars you see on the top are lower, much lower than diesel. So actually palm oil biodiesel is doing much better than diesel. Of course, if you look at the last bar at the bottom, if you convert forest to oil palm, once again, the thing is very high. And we cannot make a gain over here. We will make a loss for sure. Okay. So once converting forest, we will lose our advantage. Yeah. So this is something to remember. Now we have been talking so far only on greenhouse gas emissions, but I told you that greenhouse gas emissions is not the only thing. There are other things as well to consider, and we need to look at that, and that can have very, very serious consequences on the environmental impacts. What is that? Now, normally when we are, I do not know what has happened, but my slides have stopped moving. But I don't know, I got some message and my slides stopped to move after that. Okay, sorry about that. Now we are good. There was some room sharing and something like that, and then my slide stopped somehow. Anyway, so a lot of times when governments are promoting biofuels, they focus on two things. One is greenhouse gas emission reduction, and another is replacing energy imports with local resources. And when we look at biodiesel, for example, from these two aspects, so here you see this B100 is biodiesel. Let me get my, yeah, B100 is biodiesel, okay, and this one is diesel. So this brown bar represents the greenhouse gas emissions, and the green bar represents the energy resources. So when we look at these two things, which policymakers usually focus on, you see that biodiesel is far, far better than diesel, much lower emissions, yeah, from global warming and energy resources. However, there are many other impacts because biodiesel is an agriculture coming from agriculture. There are other impacts associated with agriculture, which we need to consider. So here you see, if we consider those impacts from oil palm farming, yeah, from land and from pesticide use, this one, pesticide use from land, etc., you see now that the biodiesel bar has gone slightly higher than the diesel bar. Even though if you look at just at the brown one and the green one, this is of course, like we saw in the previous slide, the biodiesel is better than diesel. So that means if we look only at greenhouse gas emissions or only at greenhouse gas emissions and energy resources, we get a truncated picture, not the full picture. And we are spoiling other impacts, but we didn't notice because we didn't care. We didn't think about it. So the point, I'm not saying that biodiesel is bad, but what I'm saying is that if we want to maintain the environmental benefits of biodiesel, we need to look at all the impacts and try to find ways in which to reduce them, all of them, not just greenhouse gas emissions. How can we do that? I will come to you in a moment. Just one more example I want to show you. Here you see, I'm comparing FAME. FAME is biodiesel, basically, fatty acid methyl ester, and then hydrogenated FAME or HFAME, that is the red bar. The green bar is biohydrogenated diesel. These are all variations of biodiesel, okay? And the purple bar is diesel. So when we look at, once again, greenhouse gas emissions and fossil resources, you see the purple bar is the highest, which means diesel is the worst. And all the biodiesels are doing, all the three kinds of biodiesels are doing much better than the diesel. However, once again, when we look at the other impacts that are associated with agriculture, you see in the green box over here, fine particulate matter formation, terrestrial acidification, eutrophication, carcinogenicity, and land use. There, the biodiesels are not doing so well. So this is something to beware. So how, if we want to maintain the benefits of biodiesel, what should we do? So what we can do is something like a biorefinery, where we use not only one part of the biofuel. Like, see, when we talk about palm, we focus on palm oil. But palm oil is only 20% of the palm fruit. And the palm fruit is only maybe very small percent of the palm tree. But when we add all our fertilizer, water, etc., it's for the whole tree. It's not for the fruit. It's not only for the oil in the fruit, right? So if we don't use the other parts of the biomass properly and use only the oil, our efficiency is quite low. So if you want to increase the efficiency, we use every part of it for biochemicals, for biofuels, for biomaterials, all kinds of value added. And that will make our biomass much more efficient utilization. Yeah. Same for sugarcane. If we focus only on the sugarcane juice, that's not enough. But we can use the bagasse for energy, for materials, and so on. So you have biomaterials, your biochemicals, all kinds of things, and bioenergy also being produced. And so from this biorefinery concept, where we utilize each and every part of the biomass, there our efficiency increases a lot. I'm not presenting the results to you today, but we have done studies to show that the biomass efficiency increases a lot when we utilize every part of the biomass. And that is a very important finding and something that we have to keep in mind if we want to maintain the benefits. Okay, so this is what I wanted to say. So I would like to just summarize my talk today in the interest of time. We cannot do without energy. Okay, we need energy. Okay, we can't do without it. But life cycle thinking is very important. It's necessary to avoid problem shifting between life cycle stages and between different impact categories. So we need to consider all the life cycle stages, and we need to consider many different impact categories, not just one. Like, for example, not only greenhouse gas emissions, but other things as well we should do to avoid problem shifting. Yeah. And renewable energy is not emission free, sorry, but it, of course, can contribute to efforts towards decarbonization. It does not mean that just because it is not energy emission free, it is bad. No, it is better than non-renewable energy. Okay, and we can get. But for biomass, we need some more consideration. We saw that, right? Because we have places like fertilizer application or land use change, etc., where we need to be very careful. Otherwise, we could have damaging effects. And also we need to utilize all the parts of the biomass as a biorefinery to enhance the benefits of biomass utilization. Okay, so this is what I have said so far. And two things that I have not said so far, but I would like to anyway say it in my conclusion is, a lot of times we talk about energy efficiency and think that is the solution. That is, of course, important. It is part of the solution, but not the full solution. Because if we only focus on energy efficiency, we will face something called rebound effects. Okay, because when we make something more efficient, it becomes cheaper and we use it more, and overall the use increases. That is called the Jevons paradox, and that has been, for hundreds of years, it has been observed, and we have innumerable examples of that. So the key then is sustainable consumption. So along with energy efficiency, along with renewable energy, along with all technical solutions that we can find, we must have sustainable consumption as well, which may be reflected by our lifestyle changes and so on, because we want to avoid rebound effects and in the bigger picture be sustainable. So I would like to conclude my talk with this. Thank you very much for your attention. I hope I've managed to keep my half an hour as required. Thank you.
Thank you very much, Prof. Sabir. Please don't remove this slide because yeah, the final point is very, very interesting. And
thank you.
The first about the 9 categories, as the planet's boundary is in the red zones, and not solely for the climate things, but any others categories like water, ecosystem, and so on. And I think this is we should all take into account about when we do the assessment for the life cycles. And also very nice, very clear the presentation and the cartoon cartoon picture. Thank you very much, Prof. Sabir. And also tell us about the the natural gas, mini hydro, solar PV, and so on in Thailand. This is a lesson for us. And the RE, renewable energy, is not zero emissions, and this is the clue and the final point. And I should add also about the I forgot the achievement, outstanding achievement of the Professor Sabir, that he's ranking as one of the world's top 1,000 most influential climate scientists based on the Reuters Hot List 2020. And he's also awarded the Mahidol Science, Environment, and Sustainability Award in 2022. So this is also a outstanding achievement, and we are pleased here with the three all keynote speakers that all have outstanding achievement. So then move to the time for question and answer. We have still about 20 minutes. I think first we divided to offline and online, but I cannot read in the chat box. So please help me, give me an assistant for that. But firstly, in this room, in the hall room, please for the three participants have a question, please raise hands. Any question? Okay, from the middles. Okay, please give the microphone for. Yeah, please the name and the affiliation, and yeah, and then
langsung ya Pak ya.
Ya, silakan.
Okay, thank you for the presentation. I'm Hakim Satyadi from Pelabuhan Ratu coal-fired power plant. I have two questions about its presentation. The first one is about the biomass. We found the presentation interesting, especially regarding the use of biomass in the EBT mix. We currently face an issue where with biomass affect its calorific value, impacting electricity production, or we call it derating. Are there any specific methods or studies on biomass management to maintain its calorific value that you could recommend? It's about degradation in calorific value in biomass. Is there any recommendation if we how to keep up the biomass in good condition? And the second question to to the second presentation, our power plant has several small projects. Until now, our PV has reached 20,000 kilowatt peak, consists on grid progress tracked solar power plant, green H2 system producing using PV, and this year we invest in installing 1.9 megawatt peak of solar panel. Considering of our investment in solar project and your experience, are there any long-term problems related to solar panel maintenance? This is so that we carry out mitigation and related lesson learned. And then what we must do mitigation it. Thank you.
Okay, so this question addressed to first and the second ya. Ya, oke. Silakan Pak Prof. Heri.
Yeah. Okay, thank you very much. Namanya siapa tadi? What's your name?
Namanya Mas Hakim.
Okay, Hakim. Okay.
Hakim, Mas Hakim.
Hakim from Pelabuhan Ratu ya.
Pelabuhan
Yes.
Ratu.
Pelabuhan Ratu, Power Generating. Okay, I know also previous GM ya, Pak Priyatna.
Okay,
Yeah,
Pak.
now he moved to handle Sumatera, I think ya,
Yeah.
Pak Priyatna ya.
OMBD 2.
Oh yeah,
Yeah.
okay. Last week I met him also. In case for coal firing in Pelabuhan Ratu, yeah, there's a coal and biomass ya. Nah, in case for biomass, your question is, are there any specific study to maintain the calor value? Is it your question?
Yes, sir.
Okay. So, we understand that for the solid biomass, for example, there is so many resources, so we cannot control the homogeneity of the biomass itself. So there's a trade-off, yeah, between preparation and direct use of the biomass. It means if we do preparation, so it will take cost, yeah. And then if we just use it as it is, yeah, so the efficiency also will decrease. And so the biomass should be handled in before feeding into the burner, yeah. And the heat resulting from the burning places in the power generating system can be used to heat or remove water, for example, yeah. And when the water content is reduced, the shape of the biomass is not problem, yeah. So just use the heat to remove the water content, and then you can use it as the biomass dry as possible, so the efficiency will be more higher. And to reduce the water content, you can put it around the burner place before feeding to the burner with the coal. Maybe that's one of the alternative, yeah. But of course, the price of the biomass also will be should be considered. The cheaper also the best, yeah. But dryer also much benefit for the efficiency. Yeah, thank you.
Okay, thank you, sir.
Thank you very much for the nice questions. Basically, longevity or the duration and also lifetime of a system like the PV system that you have installed. And it is great to know that you have a large scale system over there. So longevity or duration and also lifetime basically depends on few factors. It is not only one, like the quality or the characteristics curve of the equipments that you used, like solar PV, then the battery and the protection devices, power electronic devices, and so on. So they have a lifetime, and they have characteristics. And you know, there are many manufacturers across the globe. Some are very cheap, some are very costly, some are in between. So that is one of the factor that we need to consider, that what is the lifetime, what is the characteristics curve of those. And then we need to think about the weather condition and the structure that is installed or maintained. And then the dust. So solar PV dust is another problem. With the dust, lifetime is deteriorate with this. So these are some of the factors that you need to consider to see a lifetime of a system. So regular protection and monitoring is needed, and see how the weather and also the dust condition affects the quality of the time. So there are many quality parameters or the generation that you can observe, and based on that, maybe you can act accordingly or take necessary measures. Okay, is that answer your questions, or you want any specific?
Okay, I think enough.
Okay, thank you.
Because our power plant have to challenge to increase the power plant, the capacity of the, yeah. Okay, thank you, thank you.
Thank you.
Thank you, Prof. So the next. Okay, so 1, 2, 3. I think the first Pak Nugroho, Head Center, please, our colleagues.
Thank you, Professor Sabir. Long time not see you. I met you last years in Bangkok.
In Thailand, yes, Bangkok.
Happy to see you here. Anyway, I have several questions regarding your presentation. First, you know that in the world now, especially in Europe and US, they are working with the CBAM, Carbon Border Adjustment Mechanism, in terms of the selection of the technology, or in terms of the trading of the things of goods. We have to consider the carbon footprint. So my question is, how about in terms of the energy technology? We know that to select the technology, we also consider the technology readiness level, for example. But how we combine the technology readiness level with the carbon footprint itself? For example, if we select the blade, for example, or the batteries for the EVs, we know that there are several kind of the batteries available in the world with the recent technology. So how we can include the carbon footprint to select to select the sustainable technology for the future energy transition? Thank you.
Thank you. I think you asked a very relevant and very topical question, and a very difficult one. The thing is, different batteries will have different carbon implications, and even the technologies keep changing. So we have no choice but to keep evaluating and keep re-evaluating as the technologies improve, because as the technologies are getting better and more efficient, then our carbon footprint will actually decrease. So, I mean, what we could possibly do is have different carbon footprint numbers attached to the different battery technologies, for example, that are being used. But also, the battery technology itself may improve over time, and it's happening very fast these days, because more and more EV is being promoted, and as it is gaining traction and coming into our countries, so the more and more batteries are being produced, and they're becoming more and more efficient. So we have no choice but to keep re-evaluating.
Is that? Yeah, okay, short time. It's okay, yeah. Well, we have still time if you want to put it on. So the next one must please give the microphone for him. Please give the name, also affiliation. And
My name is Yustin Rawan. I'm a student at University of Indonesia. Thank you for the change. I want to ask about to Professor Saifullah. That presentation was good. In Indonesia, it's like we to know we have already a lot of potential about the solar thermal power, but waste like that. So Indonesia had same climate like Australia, but yeah, as you know, Indonesia had a problem with the regulation on grid and off grid. So the citizen like a creative thing to maximize to the off grid system. I want to ask about the potential about the nickel battery on the microgrid. Do you use about the hydrogen battery? If as I know, but Indonesia is a lot of potential about the nickel. Can nickel battery replace the hydrogen, or nickel battery is can be used to the like a 10 years ago or 10 years future? And the second is I want to ask about the controller. Do you use because I'm using the MPPT like as we know like maximum power point tracking. Like we use and I'm just buy it Alibaba Express or Alibaba. Yeah. So I want to know about the up-to-date controller. Maybe I'm last to date about the controller system. Yeah. And the last one is the forecasting system. What kind of software or do you use about the forecasting system to the thermal pan? As we know, I'm like your chart like in your presentation is using MATLAB. Is that right? If you're using MATLAB, you just train the data set or real time, or do you use like a ArcGIS or something like that? Maybe if I had a chance, I want to join your research. Thank you very much for the question. Yeah.
Thank you.
Thank you very much for the question.
Yeah, please.
Okay, so I think you have 3 questions in total. So first one is about nickel, use of nickel battery. In our research, we have not used nickel yet, but I think nickel has a good prospect as well. And considering the cost and longevity, nickel is a competitive one. Like hydrogen still is an expensive technology. So like compared to lithium ion battery or lead acid battery, hydrogen is expensive. But considering the future, and also we are thinking to reduce the price, like maybe research is going on to produce hydrogen with $2 per kilogram. So that is the future basically. And on that case, considering the longevity and long charging duration, hydrogen will be a future. And that's why now across the globe, there are a lot of research is going on hydrogen. But I think you are right that as there is a prospect in Indonesia for nickel, we can export nickel on that as well. And there is a possibility of going for nickel. Then the next one is the MPPT and the controller. So we are using MPPT as well, but for application wise, like either it is a grid connected or a grid, we need to customize the control system based on our need or based on the system we are going to design. So like when we are using a single microgrid, then we developed a control system. It is basically the control system, either a centralized controlled or a distributed control. So Drup controller, I think as you are working on that, you are familiar with the Drup controller. So the controller, what is its purpose? Is that a central controller or it is a distributed controller? And based on that, we need to customize our control system. And third question is about the forecasting, I think. Is that right? Okay, so for the forecasting that what we showed you, we use sky camera technology. So we are collecting short term, so sky camera that collect the sky images of the sky. Then we are transferring to the the values from the sky that, okay, when the cloud is coming and when it will coming in the next 3 minutes or 2 minutes. And based on that, we develop we analyze the data using MATLAB or some other software like Python. Then we identify that, okay, cloud is coming in next 1 minute. We send the signal to our controller that, okay, please start your generator because cloud is coming, no generation from solar. So we need a generator or we need to turn on the battery and so on. So we need to check the ramping time of the generator as well. And we need to see, are we going to tackle this situation and so on. So this is the way we are. And last criteria, you are most welcome. So I have at this moment I have 7 PhD students working with me under the area of like electric car, electric vehicle, optimal placing of battery and an energy storage system, and also renewable energy integration. So you are most welcome. Thank you.
Thank you. Dia cerita tadi sebelum ada 25 mahasiswa yang sekarang di Murdok. So silahkan kalau ada mahasiswanya atau Mas sendiri yang akan melanjutkan postdoc dan seterusnya di sana. So please welcome. Okay, the third question from I think tadi ada yang raise hand, Mbak atau ya Mbak, silahkan. Please give her the microphone. Okay.
Thank you.
Give the name and
Yeah,
also
my name
question.
is Helena Lina. I work at Research Center for Sustainable Production System and Life Cycle Assessment. My simple question is addressed to the third presenter, Prof. Sabir. Is it right? Since greenhouse gas emission and energy resources is lower than diesel, but there is still a lot of challenges. And energy efficiency is not one of the solution. You mentioned that. And what is your recommendation to change the usage of fuel consumption globally? I think that only one question to Prof. Sabir. Thank you.
Okay.
Thank you. Thank you very much for your question. So the thing is like this. Yes, there are issues. For example, you gave the example of biodiesel, which I presented, that there are issues not only limited to greenhouse gases and energy resources, but also other impacts which we should consider. So to improve the situation, what I presented also was to use the biorefinery idea. So by that way, we utilize every part of the biorefinery biomass to improve the efficiency, overall efficiency of the system. That is one. Second is, it's not that energy efficiency is not important. It is surely important, but it is not the entire solution. That's what I mean. That if we just focus on energy efficiency and say that now we have become more efficient, so it's fine, it's not enough. So combine, okay. So we have the biorefinery to improve the performance of the biomass energy. We have energy efficiency to reduce our energy use per unit of function. And thirdly, we need to check our overall consumption, because as a rebound effect of energy efficiency or better utilization of biomass, our energy will become cheaper, and then we start to use more because it is cheaper. We will overshoot and we will have more. So that means all these things are important, but not in isolation. We also have to think about how to reduce our energy demand and how to control our energy demand, along with the technical solutions like improving our biomass performance and improving energy efficiency. All three need to be done together. Otherwise, we will still keep having the problem of sustainability.
Answer the questions. Okay. Ada satu ya online. So from online there is one questions.
Yes, from online participant, we have one person who raised hand and would like to ask question.
Go ahead. Yeah.
Mr. Benny?
Mr. Benny, go ahead. The questions.
Mr. Benny, do you want to ask
okay,
yes,
thank
please.
you. My question addressed to Mr. Zabir Gwila. Thank you, Mr. Sabin. Regarding to your presentation, talk about net zero emission. Could you please send for us the formula to calculate of the carbon dioxide or net zero emission? And the second, I think in your research, you used of the standard for the calculated of the net zero emission or carbon dioxide? Could you present to us what is your standard do you use in your research? Thank you very much.
Thank you for your question. So normally we use the general life cycle assessment standard. And if you want to do carbon footprint of products, you have the ISO 14067 for that. Okay, ISO 14067. However, for national standards, you may, I think, Pak Nugroho may have better idea about BRIN and what is being used in BRIN. In Thailand, we have our own national standard as well, which is based on ISO 14067 as well, but okay, it has its own slight characteristics to specify. But if you're doing the calculation for EU, you may have to use the PEF or Product Environmental Footprint Standard. So depending on the application, different standards are used. They're all similar in the principle, but there are small variations in the details. So because there are many methodological choices to be made of which kind of allocation you will use, which database you will use, things like that. So there may be some slight variations between the different standards. So depending on the application that you want for, then you have to follow that particular standard.
Okay, thank you, Mr. Sabir.
Thank you, Pak Beni, Prof. Beni, atas pertanyaannya. So I think time is up, ya. It's already the time. Tapi saya ada pertanyaan. One question from my side to Prof. Shafi. As you mentioned and presented in your presentation that all lesson learned in the continent Australia island, yeah. But in Indonesia, as I mentioned before, that we have a lot of islands. So big challenge for us actually, yes, to develop, yeah, the renewable energy and so on, yeah, especially for the how to develop the infrastructures and the supply chain for that and so on. So do you have a I mean, yeah, the common and the station or something like that.
Thank you very much for the nice question. Basically, so far I have the experience that Indonesia is working towards that, and they have a climate change and also immigration mitigation target. And some of the islands already has renewable energy integrated as well, and many are on the phase. So I think definitely there is challenge, but as I mentioned that technology is upgrading and cost of energy or the production cost of the renewable energy is decreasing day by day. And if government go with a good policy and regulation, definitely at the starting, maybe we need to invest more, but with long term, it will be benefited to the country. So need policy and regulation. Also, the project that we are doing with BRIN at this moment, the climate change and funded by DFED. And on that, we have seen some of the issues that need to be addressed by the Indonesian or the Jakarta government. And on the climate action plan that we are planning to develop, we identified those that what are the barriers at this moment in Jakarta, what they need to be do to emerge renewable energy more and more in the near future. So I think there are few policy issues, need investment, and also increase the renewable energy target would be the solution. Yeah.
Yeah, thank you, Prof. Safi. So policies is, I think, the dominant things. So yeah, we have already been provided the presentation from keynote speaker, from Professor Heri Hermansyah, from Dr. Saifullah, Professor Saifullah, and Prof. Sabir. Please give them and for us the big applause. Thank you very much, and I think I should back to Mbak Novi. Saya minta maaf kalau ada yang kurang dan selalu jaga kesehatan, jaga apa? Sanubari dan kewarasan. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Wijo. That was a very insightful session. We would like to express our gratitude to Professor Heri Hermansyah. Please give applause to Professor Heri Hermansyah. And we would like to also express our gratitude to Professor GM Safiullah. Thank you very much. And of course, to Professor Shabir Giwala, please give the biggest applause. Last but not least, to the moderator who chaired the session very well, Dr. Wijo Koko. Please stay on the stage because as a symbol of appreciation, we would like to deliver some souvenirs from BRIN and from our sponsor. Committee, please help to prepare. To carry out, I would like to invite Dr. Hans Saputra as a representative of Organization Research for Energy and Manufacture BRIN to come to the stage to present the souvenirs. Firstly to Professor Heri Hermansyah. The warmest applause. Professor GM Safiullah. Next one. Okay, please give warmest applause too. Now, while for Professor Sabil Giwala, unfortunately, we will have next chance to in person. But thank you very much. Lastly, for the moderator, Dr. Wijo Kongko. Thank you very much. We would like to take some photo, maybe more photographers. Yes. Please have a best pose and smile. Oh, Professor Sabir also, we are taking your pictures. Please take, all together, all the keynote speakers and moderator, also representative of BRIN. Okay, thank you very much. Please once again give the best applause for today's keynote session. Ladies and gentlemen, as we promised in the beginning of this conference, that we will have door prize. Are you ready? So for this door prize, we will have one winner from this room and one winner from online participants. So I would like to make sure everybody is ready here because we will have only one winner here in this room and the person have to answer the question correctly, like very accurately, okay? Are you ready? Oh, I know we are so we are so eager to have lunch, but hang on. We will have the door prize. So I will mention the question and the fastest person who raise hand, just raise hand, okay? No need to stand up because I worry that you will, drop something. So let's just raise hand and then answer my question clearly after you receive your microphone, okay? So I will start with offline participant first. Are you ready? I think I can call with ICSEEA 2024 and then what? Okay, let's try that again. ICSEEA 2024. All right, so everybody is focused now. The question is for offline participant only, okay? This is to also appreciate those who joined from the very beginning. If you focus in the morning, you can answer this question. What is the meaning of Sekar Jagat? The name of the dance that we enjoy this morning. I saw someone over there on my left side. I think he's the fastest. Oh, I know. Yeah, that's okay. Everyone can join, including committee, actually. But they are very busy, so very hard. Can you please stand up, mention your name, and then answer my question clearly, please?
Thank you. My name is Sumboko from Researcher Association Union. Sekar Jagat means the universal of flowers.
I think it should be the opposite. Universal flower or which one? Sekar Jagat. So it's
Yeah, the
Sekar
word of
first.
flowers.
Can you fix it a little bit? Because it has to be accurate.
Jagat means universe and Sekar means flowers. So the universe of flowers. Salah. I'm so
Is
sorry.
it accurate? Oh my goodness. Oh, I really
Flowers of universe.
Can we just give the chance to him? Because he's the fastest anyway. Okay. So once again, Pak. Sekar Jagat means?
The universe of flowers.
Kebalik lagi.
Yeah.
Kebalik,
The
Pak.
flowers of universe.
Right. So it has to be accurate. Thank you very much. So please contact committee later to give to receive the gift. Oh yeah, I haven't mentioned the gift. It's cash. 250,000 rupiah. It's okay. Nice, right? All right. So we would like to check online participants. Are you ready to join the second door prize? Can you please can you show the screen for online participants, and then please can you show your face and smile? Turn on the video, please. Okay. Next question, since they are maybe at office or at home, I know they can answer this question very well because they have the note. So, are you ready? Show your thumb. Raise hand, like show it to the video that you are ready. Okay. So, the question for online participants. The answer, remember the answer has to be accurate and correct. Okay. Mention all the name of 3 keynote speakers. All of them. Siapa? Siapa? You need to turn your video on to answer this question. Please. The fastest is Miss Ahda Fitria. Ahda Fitria. You raise your hand using Zoom very quickly, but there is no video, so we cannot really see you. Can you please turn on your video? Otherwise, we will move to next participant. Video, please. Ahda Fitria?
Yeah, hello.
Okay, right. Please mention all the 3 keynote speakers.
The first is Professor Harry.
Full
And
name, please.
full name? Oh, okay.
Yes.
Professor Harry Hermansyah. And the second one is...
Can you repeat once again? First keynote speaker is who?
Okay, the first keynote speaker is Professor Harry Hermansyah.
Right, is it correct? Audience? Okay, okay, next.
And the second one is...
It's quite hard to find the program book
yeah.
again, yeah?
Dr. GM Syafiullah.
Professor.
Yeah, Professor Dr. GM Syafiullah.
Syafiullah, right? Okay.
Yes,
Again, the third?
and the last keynote speaker is
Professor?
Professor.
I'm wondering what kind of file that you're reading right now, because it's supposed to be easy if you just read the program book. Come on.
Syabir, Professor Syabir. Yeah,
I am too kind, right? Professor Sabir, who, please?
I don't know.
Oh, I think I have to. This is name of someone, so it's very special. We cannot change it or cut it. Professor?
Shabir.
Okay, shall I move to next participant then? Next. Ayo Mbak. Okay, next participant ya.
Okay.
I'm very sorry. This is not just not accurate, but not correct. Okay, next participant. Miss Berlian. Can you mention all of them quickly, please? Can you unmute your microphone?
Oh, okay. Thank you. First keynote speaker is Professor Dr. Heri Hermansyah. The second speaker is Professor G.M. Saifullah.
Safiullah, actually.
Saifullah.
Safiullah. Maybe there was an incorrect typing in the document. Sorry. Yeah. Okay.
Okay. And
Okay.
the
Next
third is Professor Shabir Giwala.
Are they all correct, audience? Okay. So Miss Berlian is somehow lucky. Yeah.
Thank you.
So I have one more question to you, Miss Berlian.
Yes.
What would you use the money for? 250,000.
Towards F1
You can
powerboat.
contact me. Okay, anyway, congratulations. Please give applause to the winners. Okay. So, distinguished guests and participants, we have completed half of our agenda. To regain energy for the remaining half, which includes parallel sessions with numbers of interesting presentations, we will have a lunch break, and all registered presenters and participants are expected to join the parallel sessions following your respective rooms. So allow me to mention the list of the parallel rooms. So we will have 3 parallel sessions. So the first session, 2 rooms for new and renewable energy, plenary room and room A, 1 room for sustainable transportation in room B, 1 room for green maritime in room C. And for the second and third sessions, they have similar distribution of room. 3 rooms for new and renewable energy, plenary room, room A and room C, 1 room for sustainable transportation, room B. All right. So we expect to start the parallel session by 1 p.m. and complete by 5:30 p.m. After parallel session, presenters and participants can join again the second day tomorrow by 8 a.m. One important notice, we would like to invite the head of research centers in Research Organization for Energy and Manufacture BRIN and General Secretary of PPI, keynote speakers and representative from sponsors to join the special dinner that will be held near swimming pool area of this hotel by 7 p.m. Okay. So since the parallel session will be very extensive, let's enjoy the lunch as much as we can. I would like to mention first the location of the lunch place. It's the restaurant of this hotel on the first floor. So this is second floor. So you can go downstairs to reach the restaurant at first floor. On the first floor near the swimming pool. All right. Ladies and gentlemen, please enjoy your lunch and give the warmest applause to all of us. Thank you very much, and please enjoy also later the parallel session. And don't forget to visit the exhibition room for PT Pertamina and Paragon. Once again, let's give a big round of applause for everyone. While enjoying lunch, I would like to remind you that we have seminar rules and regulation for the parallel sessions. So for parallel sessions can be attended by registered participants and presenters. Okay, let me repeat. So for the parallel sessions can be attended by registered participants and presenters. We would like you to join. For offline participants, you can go to the next room, right next to this room. And then for online participants, you can join through the breakout room. And please join 15 minutes before the event starts. And please use the name for presenter underscore article ID underscore name. For example, presenter underscore ICSEEA 131 underscore your name. And for moderator, please use moderator underscore name. For the attendee, please use attendee underscore name. And we would like to remind that the time to start parallel session is Indonesia Central Time, WITA, GMT +8. So GMT +8. So please make sure that you join on time. And let me continue with the seminar rules. Participants must activate the camera and use the background provided by the committee. Participants are required to mute the sound during the conference and unmute the sound when requested. During parallel sessions, presenters are expected to remain in the respective rooms or stand by waiting for their scheduled presentations. Lastly, seminar participants are allowed to join each breakout room by requesting to host underscore ICSEEA 2024. One more thing from me from this morning. We have told you that there will be awards for the best presenters and best papers. So please do your best. Thank you.